You miss music?
I missed the music. Okay. Okay. So
Wait, I have ping person. Like where? You said?
go to announcements channel in the general tab and ping.
I don't have that.
Are you sure?
Yeah.
You don't have the generals tab.
Wait, general? Oh, okay, okay. I was looking on the wrong place.
Okay. Okay.
uh, uh, live on then the link, and how can I ping like everyone or here
Now you do at everyone.
at everyone? Okay, that's
Yeah.
yeah. I will just pay attention a little bit more if someone.
Yeah. Yeah. Okay. So today is the day that you're gonna make h-vita live.
Oh, yeah.
We're gonna see it with colors, potentially with some sort of animation.
Oh no, Lemus, we are actually skipping some things, man. We are not messing with render right now. Because see, render is literally a function. Before that, the part that manages the tick, it doesn't care about how do you render.
Now, what are you talking about, man?
So for instance, right now what we have is a function that advances a grid, right?
Yeah.
So what we need is an initial one and to call that with recursion, right? In a given tick.
That's the thing. So apparently, Gloss has a way to do like a bouncing ball, for instance.
Oh, so they have like init and update.
Yeah. Yeah.
Oh, okay, okay.
Because we already have the function that will create the new like data structure. We just need to discover how to map this data structure to something that Gloss can actually.
Yeah, it's not only that. Like we also need something to manage this tick of the animation. If Gloss has something like that, that's great. If not, we
Yeah.
have to implement some timer.
No, but I'm pretty sure. Like I said, my advisor has he made some examples. Right. He made some examples of a bouncing ball apparently, and we have like this. Like we have a simulate, we have a window of some sort. Background 60 probably is probably the time. We have the object, and we have oh, this is probably the function move ball. This is gonna be our advanced generation um, grid here.
Okay, I like despite I really like the idea of seeing like your advisor's code and maybe copy and paste some stuff. I would like maybe prefer to see like the documentation of the library and see like where do we get, right? That would be
Uh,
the
yeah,
most
so
fun, right?
that's a good idea.
And
The
then
only
if we have
problem,
some pain and it's supposed to be painless, right? Then we take a look on your advisor's code.
that's the thing. I'm not necessarily sure how painful this will be because when you get onto this type of stuff, you get onto a library just to make 2D vectors and graphics and animations and stuff like that. You're starting to get into too specific territory, and when that happens, the documentation starts to falls off.
Wait, but this is to be a high level stuff. You are not messing with like computer graphics that I have to do a bunch of stuff from the ground up. You are not
No, I
messing with like
agree. No, but I agree with that. I'm only saying that I don't know if you're gonna have like a really awesome document explaining like everything that you want to know. Maybe the way to learn is to read the examples and execute things. I'm not sure.
so
Like I never used this. He just mentioned this to me the day before yesterday, and I was okay. I'm gonna try this out.
yeah, so like we will see like we try by the like usual way and if it doesn't work we like your advisor's code because
Okay, I think it would be faster to just run this because I want to like for instance background white. Like this seems pretty okay. We also have like a window. So, well, I don't know what this is, but I think we can execute this and like something will pop up onto the screen. That would be great. But let's try. Let's try. So how can I find examples for this thing? Oh, okay. So you see, this is the documentation. An example. How nice. Um, um,
Okay, hides the pain of drawing simple vector graphics behind a nice data type and a few display what?
and a few display functions. Gloss uses OpenGL on the hood, but you don't need to worry about any of that. Get something on the screen in under 10
Oh,
minutes.
come
So
on,
this
come
is the
on,
time.
come on. We should be scared about that library, man. You see what they are saying? Like it's
No, no,
supposed
we
to
should
be
be scared about this.
about, but we are not doing.
This?
We are not doing this. How?
No, I agree, but anyway,
Let's go.
regardless of that, I want to execute some code. I think that let's assume it doesn't have the documentation because I researched already in Hackage, in the open source GitHub page.
But you are seeing there like the examples for you to run
Where?
on the GitHub page.
Oh, here.
Yeah.
There's only one.
Getting something on the screen is easy, yes. Okay, and then
This.
go down. Usage. There's a bunch of stuff. Go down.
No, this is to control the window itself.
Okay,
Oh, you
more.
can reset. Nice.
Okay, go down. And if you want to bump the pen, okay, file is stable. I quickly make a review. Okay, and go up to see if we have any link there on the right. No,
On
no,
the right.
yeah. There we have
This link
these.
is the same
Okay.
link as this.
Oh, okay, and then we have like examples there. No, no, on the site.
Oh, the site here.
And then we have download.
Oh,
Go
we have the
down.
code.
Yeah.
Nice.
But yeah, go back. See if we have some kind of like document that they. If you go
No,
down.
like I said, I think this is too specific to ask for an API, but okay. And
Well,
like an API proper documentation.
and
Because
then
I think we are trying to find something like this, right? So data, like Haskell.
man,
We're
and
not gonna find something like this, man. Like this.
uh, actually I was expecting something better than this. But
No, this for me is the like top of the top. You have a natural language explanation.
no, no.
You have the type signature, and you have examples. For me, this is the best.
Lemus, you are having double standards. In F
Double
sharp,
standards.
yeah, double standards. Like what I mean is, in F sharp, a documentation like a regular one for you is shit, and in Haskell, a normal like documentation for you is, oh, that's great.
Man, I have a hard time finding one of these in F sharp.
uh,
A natural
really?
language explanation. Yeah. Usually, especially with like Fable and Feliz, it's just it is the
No,
same thing as
no,
Material
no,
UI.
no,
Just go.
no, 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 no. You are just hearing. Just search for F sharp Feliz. You will see the best documentation ever. Like
I didn't find that.
it's no,
F.
no, no. I'm pretty sure you already saw. Like just let's see the link because it's quick. And
No, no, no.
I
I
don't.
want to. I want to have something ongoing.
So okay,
So
copy and paste that.
okay. So, but first we need to import this. So I want to know how my advisor did that. So let's go to stack. Okay, it doesn't have in here, which means it's probably in here. This is how he made this. No, here is not. We are not adding the stuff. Where the heck he's importing the?
Well, isn't
the
always on template? Wait, he has Cabal and stack.
no, cable is inside stack. That's normal. That's normal. Okay, so I kind of don't know how
Like,
to import
isn't
it, but
supposed
let's
to be.
YOLO it.
Oh wait. Isn't it supposed to be always on the same file that you have your dependencies on?
Yeah, it's the same file. Usually
So
it's just this one. So let's try gloss to see what happens.
wait, but are you guessing the name?
Yeah, I'm guessing.
Shouldn't you have this on the site that they provide?
Oh yeah, they should.
No, no.
Every-
I mean, don't they have it?
Oh, have it. I don't think so.
Or
For
even that? No,
instance,
they have how to install, right? Download.
explore usage. No, they don't. They don't teach you how to install the
Yeah.
because this
Lemus,
is a standard.
you cannot complain about F sharp anymore, man. Just cannot. It's the same thing with Haskell.
No, but I never complain about the important dependencies in F sharp.
No, documentation and stuff.
No, this is like I said. I never saw anything like this in F sharp in my life. But
I'm saying for you that we have something even better.
okay, we can go
Oh
on
wait,
in this
wait.
debate later.
What about there on the left? Well, on the right. Don't you have the name of the
h-vita
package?
stack REPL. The name of the package is Glossman. I just want to know because sometimes you need to put the version, right? You need to put like base, and then you need to put
What do you mean?
the
Sometimes is if you want to, right?
no, yeah. If you don't want to mess around with versions and things like that, I I actually recommend. Actually, Stack does this for you. It already checks if you have a like conflicting versions of things. And this is one thing that's really good in Stack. Um, but anyway, let's see if this compiles. If this compiles, it's gonna be awesome. Let's wait a little bit. Let's copy the example. So here is the hello world example. So apparently we need to have like a display of some sort, and then we have a picture, right? And this picture is basically the object that we want to. Oh, this is how you shift it. Okay.
Window title, window size, window position, background color,
Yeah.
and picture to display. Okay. And then the picture
Yeah.
is.
The picture is a function that receives like
Oh
some
no,
sort of.
wait, wait. You read backwards, right, in Haskell, with that like dollar thing. So would be
Um,
text and then the rest up there.
you can
Like
follow that
you have
order.
the text, then you scale, then you translate.
Yeah, I think that you do this first and then this first, and then these two things like you are composing them together to the translate function. But like this DSL is made in a way that kind of doesn't matter. You only need to know like, oh, you want to do configurations. Probably is the dollar operator. But these they have their own meaning. So for instance, this is how you shift the object in the window. This is how you change its proportions, and this is the actual content.
Uh, yeah, but I really think we should be reading on the right way, man.
I don't think that will matter, but let's see. So is this compiling still? Okay, still compiling. Let's go to the more interesting example like this one. Oh,
Do they have
it
some?
has a bunch.
Oh wait, is that the what we want already?
Yeah, this is almost like what we want, right?
Oh man.
Lifespan. This is pretty close to what we
Oh, I
want. So there's four files here. We have the cell.
yeah. Begin by main because I want to see the.
Okay, let's begin by main then. Okay, so there's a function got get stdgen. This is a calculating cell. So this is the same function that my advisor was using back in the day. And then we have a window of some sort. And then this is the background color. Oh, this is the exact same thing as he was
Number
doing.
of steps per second.
Yeah, but this is the same exact thing that he did in his main.hs. This is the same thing as this.
Yeah, can you take a look on the type of that
Oh
simulation?
yeah, after the repo loads. Oh, look at this.
Yeah.
617. This is OpenGL, man. This is definitely OpenGL based.
Oh, lots.
OpenGL raw. Oh no. Let's continue then.
Lemon, so what is the config of that one that you are using right now?
Oh, this computer. Ah, it's I think it's in i5, like sixth generation or something like that. Um, it's not like it works. It does the job for me.
Well, it has
But
RAM enough to run the Sharp toolchain, right? So
yeah, no, 16 gigs of RAM, so I think we are fine. But okay, let's continue the reverse engineering this thing because, like I said, this seems to be a really, really like deep specific library. Like I never
Ah,
seen
no, no,
this
no, no, Lemos.
anyone do using
That
this.
sounds like bullshit because they are already high level, man. You are not
Uh,
messing with like Vulkan or any render API directly.
no, you did. You went to the extreme now. That's really unfair.
No, no, no. That's really high level, man. That's what one would use at the highest level to render something.
No, the highest level would be Vulkan, but this is not the highest level.
No,
This
no,
is
no, no,
pretty
no.
niche.
Highest level of abstraction. That's not niche.
No, what is niche, man? Is when very few people know the existence of.
So, okay, that would be the specialized. That would be messing with the OpenGL, for instance, the specialized thing, the bare bones, that not abstracted, not high level.
I think we are talking about two different things, man. Like this thing has 350 stars.
Oh, okay, you're
Is
talking
that
about.
is
Okay,
that is that popular in your books?
okay, yeah, we were not talking about the same. We're talking about being popular or not, right?
Yeah, I'm talking that usually libraries like this that like you just upload to Hackage because you can upload libraries to Hackage. Libraries like this that okay, somebody told you about it and then you want to use it to see how it works.
Okay, so
This is pretty common.
do, do me a favor. Can you search for awesome Haskell?
Awesome Haskell. Let me just keep track of this thing here. Okay.
Yeah, you don't need to worry about that.
Okay.
And take a
Yeah,
look if
this is
you
2.7K.
yeah, take a look if you don't see any UI rendering stuff there.
Oh, there's GUI.
Okay, go there.
Okay, so GUI.
And there
A
we have some
collaborative
stuff.
package lists. Official, okay, graphic user interface libraries.
So go there, one of those. Like maybe find the GitHub for that. If they have better documentation.
Um, okay, let me try to find the GitHub. Copyright. Don't know.
Holy, but I was expecting more names there.
Um, no, that probably there's a bunch of names.
No, I'm,
Just
I'm
change.
only seeing a few in that category of UI.
There's ray tracing in Haskell. Okay.
What do you mean in Haskell?
Apparently, there's libraries that can implement some sort of ray tracing algorithm.
And why you would not expect that?
Because I never like. Oh, Gloss is here.
He's using
Gloss
gloss?
hat raster. No, this is the Wikipedia page for Haskell about like.
Oh,
Oh, you
okay,
want to do
okay.
graphic stuff? There's all of these guys that you can try. Oh,
Okay,
this is the
so
JPEG algorithm. This is PNG,
okay, so yeah,
PDF.
go three-dimensional, no, go up there. I don't know what the fuck band. Go up there, libraries, then we have diagrams, functional meta, reactive animation.
Function.
Uh
React, reactive animations.
yeah,
Uh,
maybe gloss is one of
oh,
the
it's
comp
written in here, man. Documentation available.
oh fuck. Uh,
It's written in
yeah,
here.
maybe gloss is one of the popular ones.
Not in, I doubt it because
Popular
350.
is relative.
I agree, but let's try to I don't know chart library
No,
just to
but that
just to see.
doesn't do what we want.
Oh, it's not even up.
And also
Nice.
this doesn't do what we want.
Oh, I know what is this.
Hmm.
This was one of my first meetings with my advisor. We talked about function reactive programming. This
It's
is
like
cool.
you only update the data and they do the rendering, right?
I don't necessarily know. I just know that this is
Well,
cool.
we use that on React, man.
No, I know we do, but like, there's a whole philosophy behind this thing, and I didn't. I'm not smart enough for that. Like, I read papers about it, like articles about it.
Yeah, that sounds like bullshit.
What? You never read
No, you
papers
saying
about
that
this?
it's not in, you're not.
Not smart
Uh,
enough.
yeah.
Try to read the papers about this.
Okay.
You're gonna be surprised. Um, okay, so we are almost done apparently after 617. Oh, there's more. There's also 6/12. Okay, we're gonna be waiting a few minutes for this, unfortunately. I want to read more examples in the meantime. I think we should like. There's these examples, but there's also the other thing. hmm Okay, so the word consists of a community and a random number generator of chaos or hand of God. Okay, so this is technically the probably the grid. This is the initial world. So this is Genesis. Okay, good name.
Well, they
You
also
set.
call the Genesis block, right?
Oh yeah, that's true. And patch Genesis edit main.hs accordingly. So we have. I want to where I want to see where these types are being created. Or is this? Oh, there's a bunch of zips. Age. Man, I think this is Game of Life now. That would be really funny. Angles, scales, generate the next generation of a community. Yeah,
No,
yeah.
I think it's something more complex.
Given a collection of cells, check if it fits. Yeah, if so, add it to the community. That check must include new cells. Okay. Location fit spring, cell, overlap. Okay, so apparently there is some types that are just in the library. Yeah. Yeah. Okay. Um.
Okay, it seems that picture is one of the types that we work on and compose.
I agree. I think we need to pay more attention to this guy. So this picture, so this is the background. This is the window where it's going to be located. There's controls related to this, as we saw, like these controls. And we also have a picture, and that is shifted, and it's a scale. It has some scale, and then we have the content. Okay. It's really funny that from one example to the other, like from the hello world to the lifespan, one is really more intricate than the other.
What
But this
does
is
wait?
exactly what I
What
want.
does intricate mean?
Convoluted, like harder. Like the difference between the first example and the second is ginormous, apparently.
Okay.
But this is exactly what I want. I want to do a simulation of a game of life. I want to have a window.
Wait. I think that simulate there. It doesn't.
No, because look at this function to step the word one iteration.
Like if
Numbers of
man,
steps per second.
if this simulate it's
This seems
library
weird.
stuff, they are not talking about the same sense as us. When we mean
Are you
simulate,
sure?
of course, because it's not a library about the game of life. It's a library about graphics. So simulate, it's probably get a window, a picture, and some render rules like the ticks and stuff.
No, man. I don't.
So
I think
you
you
are
don't.
you are saying, let me see if I got it. Like you are saying that the simulate of this gloss library, if that's a library defined stuff, has to do specifically with this domain of stuff of simulating stuff like the
No.
game of life.
Yeah. I'm saying that this gloss
Okay,
library.
okay, I see. Simulation.
This gloss library is made that you have your window. This is not related to the application itself, to the implementation. You have your background color, right? You have the number of ticks per second that you're gonna do something. I don't know what it is. I have an initial thing to display. I have a function that converts whatever the data structure that you have to a
And the
picture,
update function.
and then the update to iterate like across different worlds in this particular case. So this is pretty much what we
Uh,
want.
yeah, I totally agree with you, especially because you put on the library side and they are literally advertising that like for
Yeah,
simulating.
no, this is like that's actually the main difference I think between Gloss and Reanimate. Reanimate is more about 3D things. Like look at this perspective, like Look at this physics stuff. Like this is hardcore. This is actually like this seems really complicated. This seems pretty straightforward, I would say. Um, I think it's gonna be fast to have something on display. We just gonna have to figure out this render, right? Because we're gonna have to convert a row to a picture. We're gonna have to probably it's gonna something similar to a map. You're gonna map a grid. We're gonna map a grid to the picture itself, which means that I don't know. We're gonna have to.
Like it could be like in a lot of different ways, man. Like for instance,
Oh, it worked.
nice.
Okay, so can I see the type of this
Can't you see
simulate?
on your editor?
No, I can see in the editor, but I don't think I have the. I don't think I have the LSP working in this particular Visual Studio Code. So I just want to know if I import this. If I go here and I import this. Oh, can I? Oh,
Okay, so it has the type this color.
this is the number of ticks. This is the initial
Yeah,
model.
there
This is
you
the render.
there you should have alias to a better name
Oh
of
yeah,
what
no, this
they.
should be a type. This should be a type. And then we have the next step. And then this is IO because this is gonna pop up something for us. Okay, so now we should have everything to have the hello world working. So let me pick this
Uh,
and let's go to
Yeah, but I
display.
would be more interested in the other one, the simulation one after that.
Oh no, of course, but I want to see if this works. Okay, so this is apparently this is working. Let's go to
Yeah,
main
but
and let's import this guy. Oh, this is already imported.
wait, Lemus, wait. There,
What?
yeah, I was thinking if you were like executing this there and importing on main to get the side effect, but no, you wrap this in a function and then call that on main, right?
Yeah, no, not necessarily. Yeah, I'm gonna call this function in the repo and see what happens.
Okay.
Tab character found it here. Okay, so this is not. Um, okay, yeah, that this can be a problem. Apparently, the guys not they didn't indent it correctly. Apparently, which
Okay, where is
sucks.
your formatter?
I didn't install one,
You
but it's
can.
complaining about tab character found here and in 23 locations. So this is display line 5.
That's a Haskell thing. If they are complaining about the fact that you have a tab instead of spaces,
Oh, it's
go to
because this
your
is
VS
using
Code.
no. This is pedantic. This is because it's a warning.
No, no, no. But
So
go.
it worked.
Wait. But go to your VS Code.
Okay.
Go down there. Oh, it's already using spaces.
Yeah, I just copy pasted the
Oh, the
thing.
guy has. Oh, the guy has.
Yeah.
Okay. Can you create a dot editor config on the root of h-vita? Oh, okay.
Sure.
Okay. Install that like editor config. No, no, no. Install the editor config.
This one.
Yes. Now you can like right click on your files and generate. No, on the file explorer.
Oh, okay.
Yeah.
Click right click where?
Yeah. It should be there like h-vita. Generate. Yeah.
Generate to here.
There. So where is it? Oh
Here.
yeah. And then
Ident size. It's space and two spaces you want.
wait. Is that you have something to avoid that? And styles. Okay, maybe go to that link that they have editor.org because I think they have something that works. Did that open something? Oh. Oh.
Oh, so do
Whoa.
you look at that?
Oh, that's quite a thing.
Okay. Okay, nice. Cool.
Oh,
Now,
Mageta is here.
oh, he's in the chat watching
Yeah.
or something like that. Okay. Okay, so now we need a way. We need a way to make a grid, right? Because I think that what we are actually interested
Oh,
in is this
first you
guy.
want to like generate the static version of like one generation, right?
I want to have a picture. That's what I
You
want.
already have one.
No, I have one, but I don't have the right one. So we need to understand what the render function does. Let's explore that.
No, wait, Lems. What do you want? Are you trying to use the other example already of the
Yeah. No,
simulation?
no, no, not the other example.
So
You see this
okay,
picture?
you want to use the static one, but generating a static version of like one generation.
Yeah,
Okay.
pretty much. Oh, when I close the thing, it actually closes my repo. That's sad. Okay, but what I want to do, I want to understand what is the type of the picture, right? Because apparently we can do just the picture first. So you have one generation. And then we go onto the hassle of understanding the simulate one. Oh, it is. This is the thing. 4 lines. So we have a type called world that
But
I don't
wait, we
necessarily.
don't need that render, man.
No,
That's
we need this render, man. Because this is the render, this is the function that picks whatever your data structure is and generates a picture from it.
no, it doesn't seem to be whatever, right?
No, no, in this particular case, it's the type world. I don't know what world is, right? But what my guess
Wait,
is
is
that
this user defined?
yes,
Oh, okay. You want to see how they are doing,
how
right?
to make a grid to a picture. That's what I want to know. Mhm. Okay, so I want to know what's the. We need to understand what's. Can you give me information about world? No. Um, that's quite
But
interesting. Why the heck I'm not?
wasn't that user defined, man?
No, no, this is not user. The type is not user defined.
Where is
Oh no,
this
it is. It is.
file?
It is. It is. It is. You're right. You're right. Okay, so there's something called community standard. I think this is for standard generation, and this is an int of whatever. Oh, it's here. Consists of a community and a random number generator. Okay. So we need to understand what's a community now.
Lemos,
So what's
isn't it better for
community?
you to go to GitHub,
Oh,
take a look on that?
oh, it's just a list of cells.
Yeah, man,
Interesting.
stop. Take a look at user-defined code. Like, go to GitHub and let's see what methods do we have, like in the signature. Maybe they have some comments there.
Gloss, graphics, gloss. Okay, so this is pretty common. We have an
No, no,
internal
no. Why would we need inter?
because this is where usually the primitive types live.
But we only
Uh,
want like the API that we have available, right?
no, but this is the API. All these folders, this is the API that we have. This is we can read this thing for days. Okay, okay. Yeah, so they have something called a point apparently, which is fun. I think I already know how to make it, man.
From looking
Yeah.
at that,
No, reading this, reading this. I think I already know how to make it. Because let's go with the idea that we have a list of cells. He has a list of cells. What is a cell, you may ask? A cell is some sort of like this is a type constructor, right? So this is basically like a product
yeah,
type.
I
And then you have the center of whatever the cell is, right? So this is this is like a coordination, like x y, and then we have the radius of the cell, so this would be like a circle. And then he's also using this sort of remaining lifetime, but this kind of doesn't matter. So what we need to do, so apparently we need each of our cells in our grid, they need to be mapped to these cells.
that doesn't.
We need to have some sort of coordination, so like some
No, no,
x
no.
and y
No,
spacing.
no, we don't. I don't really think.
I
Wait,
think that that's the case. Let's just check the point type. Internals,
Okay, maybe
interface.
we do.
Okay, so I don't know. State, backend,
Oh, maybe on the
coma.
mapping of the matrix, can
Yeah,
map those and
yeah,
render.
yeah. That's my idea.
Yeah, but that information will not be on our cell type. That will be basically during the mapping. You want the column and the row, and you will use that to know where to render. So we will not have that on our types.
No, but we have a function in data.matrix that provides us the where the thing is.
No. What I'm saying is, know when you are mapping a matrix and you are getting the row and the column, you will
Yeah,
use that to render in a certain place. But
yeah.
the number where will be rendered, it's not inside our type. We
No,
are
where? No. What I mean with where? Let's make myself clear. So I'm say this is where this number one, it's being rendered at the top, like column 0 and row 0.
hmm?
Thanks, Magetta. Really encouraging. The purpose is just to record, though. But anyway,
Like it.
yeah, he just commented on the chat, but on the no, not on the chat on Twitch, the chat on Discord.
Oh, okay.
But let I want to go back. I just want to understand the point thing. Oh, lies with a rectangular box that is oriented on a yeah, it's XY plane. You see, the points P1 and P2 are opposing points of the box, but need not be in a particular order. Okay,
Oh,
I
Lemus, wait.
just
I think
okay.
Lemus. Actually, I don't think. I think we only need one thing: how to render a square, and that would make for us.
How to render a
Yeah,
square?
if you know how to render a square, I can make you render the grid.
Okay,
I
you want a square,
I
right?
think.
Okay, there's not a square in here, but there's a bitmap. And here's the bitmap. And this is Lena, of course, classic.
Could you get
Hmm.
results searching for gloss? How to render a
Oh,
square?
gloss Haskell render square. Okay.
Okay, yeah, that's exactly what.
What a coincidence. Uh, okay, so there is no existing. Let me make this bigger. There is no existing gloss function that will take an arbitrary picture and move it to its top left corner. All
Sure.
existing transformation functions in gloss are relative, and there's no way to make an
Oh,
absolute move to a specific point.
holy fuck, that's weird. But we can work with that.
Yeah.
Like you have like a how can I say
Oh,
a pencil, right?
rectangle. Rectangle solid.
What is that? Something from
Hmm.
the live?
I don't know. Let's check that.
If you have the
So
time, bro.
import graphics.
But what the fuck
Graphics
is that
gloss.
if you were like with a pencil, in one place, and
Yeah, yeah.
if
It's
you
really animation centric.
have to move
So
your cursor.
okay. So rectangle. Oh, solid. Oh,
Load
interesting.
picture.
Interesting. So I kind of want to render that. Let's try that. So I'm gonna have like a rectangle.
That would be
Rect.
instead of the.
Yeah, instead of this one or like this one, we're gonna just call a rectangle, right?
What is the type that they are getting there? Is
The type is a float to a float.
oh,
So
and
I'm
returns you
imagine,
a picture. Okay.
yeah. So I want to just instead of doing like this, I want to just do like rectangle. I'm gonna put parentheses just for the sake rectangle, and then we pass I don't know 10 10, and this is a solid rectangle
Wait.
apparently.
Can you use like 10 and 20? Because if that's coordinates, you will want like different.
Oh yeah, that's a good move. Okay, let's try that. Okay. Okay, so it didn't work as I wanted.
Oh, rectangle.
Oh, I forgot the
And
N. Yeah. Okay. Okay. So let's try. Okay, it compiles. We have a warning as always, but let's now try test gloss.
Oh wait, can't you run in a different?
Oh,
Nice. Oh,
oh, okay.
it's like width and height.
Yeah.
Now let's translate to 0, 0.
What do you mean by 0, 0, man?
Let's translate 0, 0, the coordinate.
You mean using
Translate,
translate that
yeah,
this?
like the one that we have already on the Hello World code. Look at Hello World.
Oh, okay, okay. So you mean this?
Yeah, translate to 0, 0. We can use the column and row to know where we are going to translate.
Oh, okay. That makes a lot of sense. But I'm actually kind of curious now that you just said that. Let's try
Yeah,
to
but
pick this, and
but
instead of putting text, let's do this.
not scale. We want the same size, right? And you
Yeah.
can use
I don't know. I
1010
don't know.
now.
But can I do this type of thing? Like,
But yeah, but use it. Oh, if you can scale that thing. Oh, I think they can scale any kind of picture, and that would be awesome of an API, man.
no. But I'm worrying about do they have like overloads and crap for this?
I
Like,
think they are
what if I don't want
Lemus.
scaling?
Lemus. Okay, you can just not use it. But what you were trying to say isn't that if they scale any kind of picture, because that's the type that they worry about. Doesn't matter if it's a rectangle or if it's a text. Well, I imagine so.
Okay.
But
No, but let's try
hey,
your idea. Your idea is awesome.
try to execute it. Not there because it's a bunch of trouble to run that stack repo.
No, but the problem is that every time I close the image, this stack repo for
No,
some
that's what
reason.
I'm saying. Can't you execute the project in another terminal? Like, can't you
Oh
put things in main and just run the project? So, and
no, but we can have two repos.
but it doesn't solve the problem. You still have to like,
No, we can use one just for like messing around with the types and understanding them, and another one to execute the pictures.
yeah, but only time you have to run the stack repo again. That's a lot of time.
Yeah, I agree. We could put into the main, but we're gonna have to discover how to save
How
the
to?
picture.
What do you
Yeah,
mean?
saving like I don't know, JPEG or like PNG.
I'm not sure. What do you mean, man?
hmm
Like,
So there's a
main function in Haskell. Does that has to have a specific type?
no.
So can't you just get this function and use it on main and run the project?
Yeah.
Try that.
So let's go with test gloss.
Yeah, but is it IO?
Yes.
So how do you run the project in test?
Good question. I think it's stack run, if I'm not mistaken.
Okay.
But I want to understand how we can do the thing that you said. How can we translate like from one position to another position? You know?
Yeah, I'm not sure about the composition part of all the rectangles that we want
Yeah.
to.
Oh, but we can check that. It's just to check the picture type. So um, for
Okay,
some random reason,
but
I don't have here.
can you
So I
search for? Oh wait,
gloss. And then I want to know everything that you have about the type picture.
oh, like the functions
Oh,
that use this.
okay.
Oh, that's
So
nice.
it's a bunch of overloads. It can even be a list of pictures.
Not
Interesting.
overload.
No, yeah, I'm using like I'm forcing the naming. Oh, here it is. So you can have a translate.
But that's so weird. Like actions are as a picture. What the fuck? That doesn't.
What actions you mean?
Uh, like for instance, translate. It's like kind of an action that you do on a picture, but you are composing that, and then you are
Oh, I
calling this
see.
a holy fuck. But that's quite good for composition, right? It's just
Yeah.
weird on the semantics.
No, yeah, the semantics are weird, but yeah, that's pretty because then you can compose this with
Yeah,
this.
holy fuck, man.
Oh, that's smart as fuck.
Yeah, that's really nice. Oh,
That's
okay.
smart.
So let's see how can we do it. We would start
Let's use
with
this.
wait. We would start with a rectangle. Which one would be the rectangle?
Um, let's just start with a rectangle just to see. So like this is basically what we want, right?
But first try to run the project like from main because that would get us a bunch.
Yeah. Okay, but let's just this is not gonna compile. Let me just put picture in here. Okay. So let's now try to run this thing. I think it's a stack run. I may be wrong.
You can do stack dash dash help.
Yeah, no, but I want to YOLO it. It's 1, 2, 3, 5 out of 5.
Fucking tabs.
Fucking tabs. It's almost. We are already in like 58 minutes long, and we just discovered how to display a rectangle, man.
Magette is bullshitting about your help on on Haskell. He's saying that top is better, the Okame one.
Oh, okay. So it worked.
Oh, but what is our translate for 0, 0?
I don't think that's a good question. Yeah, as I saved it.
Do we have? Yeah, we have translate.
Shift the text.
Oh, what the?
Window size, window position.
By the way, we are not choosing colors, right, to handle this, to execute this rectangle.
Yeah, no, yeah, we're not choosing colors yet, but we can because we just saw that we can compose them. Because we can have a color, and then we can compose them. So, oh man, this is nice. Like this idea of like every single sum type, you can actually put another picture, and then you can have a stack of configurations.
You have like a gigantic and nested like picture, right? And then you go like unwrapping those and render stuff.
Okay, so we kind of want to understand then how we can get. Oh, I can zoom. Okay.
That would be nice if we can do while the thing is running, right?
Yeah, no, that would be really nice. That would be really nice. Okay, so let's try something different now. Let's try. What is this guy doing again? Oh. Okay, so this is probably the coordinates.
Oh, hey, Magetta has some tip on how to improve your code.
Go on.
Adding parentheses just for the sake of listeners.
No parentheses having this crap.
You are doing that, man, as you often do on translate.
No, but now I can remove this parentheses.
No, on translate.
No, but this was already here.
Yeah, but you see, you don't need that.
No, but this was already here. That's fine. Okay, so let's try something different now. I want to. The translation is not clear to me. What exactly is doing because we can see the final result.
It's relative. It's fucking relative, right?
But relative to what?
To the square. Like we are on the mid. Oh, okay, but
so relative to what exactly?
Okay. Just put like less 50 in both.
Okay. So minus.
I said less, right? But minus.
This needs parentheses in this case.
What the fuck do you have to parse this Haskell code, man? Do you need parentheses on it?
When you're using this operator for this specific case, like to make the numbers negative, usually we put parentheses.
Oh, that's a bad parse.
That's a less strong parser, I would say. Like this is just more convenient to the parser itself. It's not convenient to the developer.
I see.
Okay. Okay, I hope it's faster now because I already did once.
Man, GHC is supposed to be fast, right? So I think your computer is really
no, but that's possible. No, but that's possible,
oh,
right?
See?
Okay, so it's relative to the middle then?
Yeah, but what is the middle, right?
No.
Like what
okay,
is the
you have a point.
Of the middle?
We need a color. Can I put red?
Wait, maybe it's the size of your screen. So window size. What is the size of your screen, of your monitor?
It's ultra wide 1080p.
Yeah, so put there like the width and the height of pixels on
your
screen.
Okay, so this would be holy man.
Window position.
Display manager. Is that the thing?
It's
No.
like 2000 and
Yeah, it's the same as yours. You know
oh,
yours?
okay. Yeah, I think so. 2, 5, 6, 0, and 1080p. Yeah,
Yeah.
not so sure, but
No, but I guess it is. But there is also something called window
yeah, put
position.
that on 0, 0.
Okay. Um,
That
okay, so
would
I need
be
to
like
close this.
full screen, like quote unquote full screen.
Yeah, that is probably full screen.
Yeah, not really full screen because you have the board and stuff, but it should
Yeah.
occupy your whole.
Yeah. But hey, if that works, that would be interesting. Oh, it's not
Yeah,
yet
but they
here.
have a pretty strange system, man, for coordinates.
No, I agree that the um,
Uh,
holy Jesus,
why
that's a bunch of red.
why is that red, Lemus?
Because I changed to red instead of white.
What have you done?
This is pretty strong, right?
Okay, so let's get those measures that we have and divide it by 2. That should be where you are rendering.
What do you mean divided by two?
So CR C, oh man, that looks so funny for some reason. But CR window size, like if
Windows side.
yeah, like if you go on your code, you have
Oh,
your window size, right? I'm
oh my God.
guessing that we can get the center of it dividing by 2, right? Game of life. Oh,
Okay,
no,
so
no,
you
no.
want to divide
H
this by two?
h-vita. Yeah, no, no, wait. It's actually h-vita, right? But
h-vita.
what I'm saying is, no, not dividing there. I'm saying
Oh,
that for us to get the center, you see, because knowing the center, we know how many we have to translate to get to the like corner of the screen. See?
okay. So your suggestion to put this in the window position? We're gonna change this guy
No,
then?
no, no. What I'm saying is, uh, we want to know where the rectangle is rendered by default, and
Yeah.
we are seeing that is on the middle, right? So
No, it's a little bit. It's a little bit not in the middle.
no, no, I'm supposing. No, no. Right now we are translating, right?
No, right now we are translating.
Okay, but when we are not translating, is it the middle of the square is on the middle of the screen, or the corner top left is on the middle of the screen? That would be interesting to.
I think we're gonna have a hard time diagnosing that, but
I know how we can do it. We can do a
oh,
really
okay.
small screen, like I don't know,
Oh, okay. Okay.
see,
Yeah,
like 40 by 40, I guess,
that's fine. I
and then
guess
like a 10 by 10 square.
10 by 10. Okay. I'm not gonna translate it then.
Then we can see if it's like on the middle or it's like 1/4 of the screen. Oh man, it's Game of Life.
Really unexpected, huh? Because it's really cool.
Is Haskell supposed to be fast? uh,
Not when it, not fast if you're not exploring the laziness though.
no, no, but
Like you can make Haskell code really fast if you make it like you can if you exploit the laziness.
wait,
Here's our
Lemus.
result.
Lemus, but you are not doing shit. You are just rendering something. It should be like really fast to compile.
No, this is OpenGL. And this is not in C.
No, no,
So this
no.
is
But I mean build. Oh, okay. You have a bunch to build.
yeah. This is OpenGL,
Wait, but
folks. We're not talking about
wait.
any
But
curses.
it shouldn't rebuild all of our dependencies every time. If he.
No, he's not rebuilding the dependencies. I think he's loading the dependencies.
Oh.
Because as you can see, only display changed. Only the file display changed. But anyway, we have here our 40 by 40 whatever.
Oh, this is not what I expected. Like,
No, but I think I changed the size unintentionally. Let me run this again.
or is that because that's the minimum size?
That's possible. Oh, it's there.
Oh, but it still doesn't make sense because my theory, if that's like 10 by 10, was that it either would render on the middle, and that's what he did, but would be bigger than that, right? Because 10 by 10 is supposed to be
Oh
one.
man, it's so small that the close button is the only button.
Okay,
See?
let's do it like 400 by 400 and then do like
Okay.
100 by 100. Because my theory was the following, Lemon. Like the square that we were rendering is 1/4 of the screen, right?
Yeah.
So if you are rendering the middle of the screen, you are beginning by render the corner that is like top left, then you will have like one quadrant of the
Yeah.
screen as black. Or you have on the middle, but you have on the middle is occupying quite a big chunk of your screen, and that was not being the case there.
I think that the translation is in comparison to the middle, man. I'm almost sure. See?
Yeah, like that's so
I think the
weird, right?
translation is converting. Yeah, this is weird. This is a really weird modeling to do
Like
this.
it seems that they are using different scales, like for the screen and for the rectangle. Well, but now
Oh
that we know that is on the middle
no, but we can do something fancy. I think.
scale.
Yeah, because I want to explore these pictures, like having more than one. I think it's gonna compose. Like you have two rectangles, you know.
Yeah, but that would be probably either random position. Oh, oh, okay. I see what you have, man. Like if you do two different ones and they will be with different translates, you can interpolate those, right? That?
Yeah, it's almost like interpolation, right? So you're gonna combine one picture with one configuration specific,
Okay,
and then you're gonna compose that with the other one.
let's do it.
Okay. Okay, so this is the type, right? So the rectangle it always returns a picture. You're gonna do pictures, and then you're gonna put rectangles inside this.
Yeah, two rectangles, but one of those has like a bigger translate to the right or something, right?
Yes.
Oh.
Rectangle one, and then we can just
Wait,
copy paste this
we have
guy.
we have some levers here, right? Because if we want to do something else with UI and Haskell in the future, we already know some things, right?
Oh yeah, no. In the future, if I ever want to do UI again, I already know something.
Yeah.
Right. So we're gonna do pictures, right? And then this is the type constructor, and then here we need a list of rectangles, like this, something like this.
But
If this works, it will be it's gonna be definitely interesting. So let's go, because we are almost with all the pieces to make the grid.
uh, yeah,
If this works and
maybe.
we understand how it works, we can make the initial generation.
Oh,
Okay, so oh, I know what's wrong. This is my fault.
14?
I think this is like this.
Why? Why?
Not sure is it yet.
I would be astonished if that was
Okay,
the
no, no, it's
case.
not. It's not. Couldn't match expected type.
Oh, okay.
So it's saying that it's expecting a
Oh,
picture.
wait, go back there, go back there. You need parentheses, I guess.
Oh.
You need parentheses. Yeah.
Oh no, it's because the indentation of this thing is really weird. Like this is weird. Like, can we agree that this is weird?
Yeah, this is weird.
I think it's pretty weird. So okay, let's see if the parenthesis solves the problem.
So
It appears so.
+1 for the parentheses, folks.
+1 for the Lisp folks. +1. You are with the score like -100 or something like that.
Oh man, that like one of the best advices for Belani, man. Always answer leverage. Oh, not from Belani, but
Oh.
oh, oh, okay, because it's on the center, right? Oh, okay.
Yeah,
Yeah,
yeah.
we don't have enough offset to get out of the hundreds, so you should
Yeah, but
have.
I still don't understand how we're gonna map this to like a grid, like a 10 by 10.
But that's easy
Oh
because
yeah,
yeah, because we have like columns and rows.
man. Let's do it then.
Okay, let's try.
Uh, we're gonna have a function called render, and this
Oh
function picks a
wait.
grid.
Okay,
What?
okay. I have some bad news or good news. Like, oh no
What's
no
that
no no
supposed to
no
mean?
no no. Wait. It's because the easiest way would be to render everything like starting from the center, and then go into like right and down. But then our image will not be centralized. But I don't think that's a problem, right? For now.
I don't know. I just want to see some cells on the screen. That's
Okay.
my goal.
Okay.
So let's import everything that we need. So we want to have a grid, right? We want to have a grid. And this thing will return a picture.
Yes.
Okay. So what exactly this grid we
We
need to
are
do with this grid?
mapping the matrix.
Okay, so we're gonna do a function. We're gonna probably do an fmap with the grid, and
And
then
then we will apply that on the constructor of pictures.
we're gonna apply that to the constructor of
Yes,
pictures.
because it will generate a list of pictures, right?
Okay, so let's make a function called make
Uh,
display.
I don't think we need intermediate functions for that, man. It's like literally fmap, and then you compose with the constructor of.
But we need to have the function that we need to fmap is not exact is a function from here, I think,
What
because
function?
we need the coordinates. We need the coordinates of this
Oh,
grid
yeah, we already using this function. Just you see,
somewhere.
yeah, it's just you see on the other file, man.
Oh, okay, that's true. We're already using it. So it's somewhere something like game of life, I think. There's a function in here that provides us about everything that we need. Um,
Fmap there, no.
no. Cat maybe is also no.
Where are we using the grid?
Oh, is this one, map boss.
Oh,
Map boss. Okay, so the map boss picks provides us the cell itself, the value of the cell, and also the location. Okay, this is cool. So we're gonna do import data matrix. And what we're gonna do? What are we gonna do? We're gonna do instead of fmap, it's gonna be map boss. There's a function f.
one question though. Is it read abstract for you? Like, can you map that type? Does he know that is a list of? Does he know that is a matrix?
What map boss?
No, grid. Yeah, if map
Grid?
boss knows that grid is a
Yeah,
matrix.
it knows. It
Okay,
knows.
not abstract, right?
Yeah, it's because it's reading from this file here. It's reading that a grid is a matrix of a cells.
No, what I mean, if it was abstract, he would complain that it's not.
Yeah, no, that's definitely.
But do
Okay,
you
so now we
have
have the
that
location.
in Haskell, like abstract type? Is
Yeah.
like if the implementation was private, right?
Oh, this is because we are exporting everything. We can make
No,
this
no, no, no,
private.
no. That's not what I'm talking about. I'm not talking about not exporting. Well, maybe
You're talking
that's how
about
you
abstract types Haskell. What do you mean about with abstract type, man?
like search for Alcamel, man.
Oh,
Abstract
here
data
we go.
type.
You're talking about this
uh,
parametric type inside?
no, 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 no.
No.
It's basically like I can have a type in NoCaml and not say to you what is the implementation. So if I said like,
No, that's possible.
oh,
That's possible.
grid, it's equal to matrix, but who imports this code will not have this information. So map pos would fail.
Oh, okay. No, you're talking about something different then. I don't know. I never did that.
We use
I
like
had.
module signatures for.
Oh.
It's basically like on the implementation file, you say something is equal to something. But on the interface, you just say, oh, we have type T. You don't say the
No.
implementation of type T.
Okay, I think it is possible then, but I'm not. I have to figure out the details later, but I think it's possible. Okay, going back
Oh,
to our
by the
thing
way,
here.
in Rust, would be declaring like the fields as private, I guess.
Oh, okay. Okay, so what about making each cell a grid like a rectangle 5 by 5? No, 10 by 10.
Yeah, like you can see that inside of F. There is where you will choose.
No, but the thing that we're gonna do with F.
It's
Um,
exactly that. We'll get like the position in the matrix, and we will use that to render something and translate to a certain place based on where we are on the row and column.
Mm, mm,
And
okay,
then
so
just apply the constructor, man.
we're gonna do something initially because I just figured out that we also have dead cells. So if cell
No. But what changes is only the
dead,
color, right?
then we're gonna have a blank. We have a
Ah.
blank type for picture, right?
Oh.
Yeah.
Okay. That's probably a lot better. Yeah.
And that if that's not the case, if the cell is not dead, we're gonna do something about it.
Okay, that's
Uh,
really nice, Lim. We will not
uh,
not render the
yeah, we're gonna just skip the dead ones.
yeah.
That's my goal. So let's try to just translate. I don't know exactly which things you're gonna put in here yet,
Yeah, but
but
it
I
has
do
to do
know
with the location.
it has to do with the locations. That's for sure. We're gonna make a rectangle solid, right? And that's gonna be a 10 by 10. Now we need to do some sort of arithmetic operation with the location to understand how
Okay,
to translate it
what is
properly.
the first location? Is it 0, 0? Is it 1, 1?
Let's imagine that is 1 1. Yeah,
1, 1.
1 1. Pretty sure. Pretty sure.
So, man, I think we can pretty much just multiply, yeah, but you have to take into consideration that you need to multiply enough, have some offset one for the other to be like just wait,
That's hard, man. Because this depends on the window size.
wait. No, it doesn't depend on the window size. It only depends on the fact that you are rendering from the middle. So, for instance, if I run one of 10 by 10, then you need to offset by 10. Yeah, like multiply by the same size that you are using on the rectangle. Yeah, like basically do column, uh, column times 10 and like a row like.
Okay,
Oh
let's spread it up for
no!
that.
Wait,
No, no window
wait.
dimensions.
Which one? It's wait.
So, I don't know, display cell size.
Wait a bit.
There's gonna be a tuple of two integers.
Yeah, I think that's it. I think it's like row times 10 and
Yeah.
column times.
Okay, so let's
To
display
be
cell
more
size.
precise, it will be row like
Mm,
times the 10 in the y-axis, right?
So it's gonna be the wait a bit. It's gonna
Like the row should tell the y-axis.
the row should tell the y-axis.
Yes,
So this is here then.
I think so.
Okay, so there's gonna be row times
10.
10, and then this is gonna be column times width. I'm
Where
gonna
did
use the proper
where
names.
are you defining the? Oh, nice. You are defining. Oh, outside. Oh, nice.
Okay. Okay, let's see if this makes any sense whatsoever.
No, it will be some completely bullshit, but let's
Bro, it's gonna
try.
be really bad at the beginning, I imagine.
I'm pretty sure.
Okay, so
Okay,
let's
yeah,
try.
just to be sure to say that the module system for Okamo is the best one.
Test grid. And we're gonna make each cell 10 by 10. Okay, this seems.
Let's reasonable. I don't think so. I think we will be completely messed up
Okay, this is wrong.
if
Okay, so I'm doing something wrong in indentation of this crap. I think it's because it needs to be like this because of the where,
you
which
have to
sucks.
worry about indentation. It's not a good language.
Unfortunately, I think this is the case.
Well, maybe it's not as bad as F sharp, right?
It's not as bad as F sharp.
And you don't have phantoms.
Oh, okay. Okay, so this can't be an integer, unfortunately. This needs to be a float. And this guy is gonna be like this. Kind of makes sense. Okay, so now it's complaining that. Oh, it's because. Oh, I know. It's expecting an int to int because I'm doing a multiplication with
Oh,
an int and a float. I hate this. This is when this is exactly what I told you. Sometimes you
uh,
want to upgrade types simple types to like ints to floats, because we need to do something like this.
Actually, I like that.
No, I like that because that brings type safety, because you're not relying on the compiler to guess which type should work. But sometimes you just want to multiply a float with an integer. Come on.
Yeah, no, I don't have a problem with that. No, it could be shorter, right? How to translate that? But
Wait, what's the type signature of map pos? Map pos. Oh, this returns a new matrix.
oh, okay, okay. I forgot. It's not a list, but we have some flatten, right? We should have
Wait,
flatten, man. Matrix to list. Just search for that signature.
no, wait. I think I have an idea. I'm
Lemus,
pretty sure.
it's literally flatten the matrix to list.
I don't want to make that, man.
Why? Though?
Because oh no, you're right.
That's
It's
exactly the
because
type
this,
signature that we need.
yeah, it's because we have a bunch of each rectangle is its own picture,
Hmm?
right? Oh, okay, that makes sense.
But
And we do
hey, hey,
have
hey, are we composing the list of pictures into one picture?
like what I want to do. Like, can we agree that this is not, no, this is map pos. This need to be map pos.
Okay.
But we are picking the current grid, and we are transforming, instead of being a grid composed of booleans, it's a grid composed of pictures.
Okay. Then we need to transform that to a list, and
Then
then
we need
use
to
the
transform that.
constructor.
Yeah. So this will be like pictures, this, and then we're gonna have to do something like from to lists. I think to list.
Oh, that would be a good name.
We have list function somewhere, diagonal, list conversions
Oh, from no,
to list,
yeah, to list.
to list. Okay, so this apparently, potentially,
That sounds easy.
this should be the thing. Okay, so let's try this. Oh, compiled, man. Holy, this is
What?
next generation.
What about that, huh?
I bet you didn't expect that shit to happen.
That's really episode shit.
Oh my god, it's gonna be wrong. I know it's gonna be wrong.
Of course you
Unfortunately.
will be wrong. It's the first try.
1 hour and 25 minutes, but okay.
Oh, okay. I was not even keeping track of the time.
No, but this is exciting, man. Because then only one. How nice.
Where is our translate? Let's see. What the fuck are we doing wrong, man?
Okay.
So okay, where F that receives row and column and
Yeah.
okay, because of the image. If cell is bad, then black. Else
Hmm.
we do a rectangle with a width, height, and then translate that. That
Yeah.
sounds okay to me.
I want to get back to the.
Now I would like a debug as in
Yeah, that would be great. Okay, this type checked, but we are doing something really wrong.
yeah, our logic is very wrong on that app.
That is false.
Yeah, it's the F, man. Somewhere along the F. Maybe it's like 22 and are doing a rectangle of the same size that should be then translating.
I'm guessing that they are all wrong, and they are all in the same place. So this is all the rectangles like combined in one top of the other,
Yeah,
but
I would bet that.
yeah. Which means that this is, but that doesn't make sense, right? Because the row and the column, they are always
Oh wait,
different.
what is the grid that you are using, man?
It, oh, it's a 3 by 3.
But it depends. Are all they alive or?
No, they are not alive. All alive. We have only one.
Oh,
one alive.
fuck, it's right, man. Oh, Lemus, come on, man, come on.
Okay, let's put the beacon then.
We were fucking.
No, but let's not say that this is like correct still. Okay.
Yeah, we don't know yet, right?
Yeah, but that's the thing. I kind of want to see the boards of the grid. You
Yeah,
know.
we will work on that. But also, I would like a border on the cells, like between the cells.
Oh yeah, that can be a problem.
No, it's only a matter of spacing.
No, it's a matter. Yeah, it's a matter of spacing. But we're gonna see just how we're gonna differentiate 10 cells, like a group, a square of 10 by 10,
Uh huh.
and a big one because they are all glued together.
And the big one, I'm not. Like what I imagine is just having some padding on the cell. So. Oh.
Is
Oh
this
yeah.
right?
No, no, yeah. That's the thing that I was talking. Yeah, this is right. This is 4. See?
4.
Yeah.
What do you
That's.
mean?
You are seeing 2 dots, right?
Yeah.
Each one of those are 4 cells, I guess. See,
Oh.
but we will solve that with the translation part. The translation will make our borders right.
No, but this
Why?
is totally wrong, man.
What? Is it?
Yeah, because it's the opposite of what we
Oh,
want.
wait. That's really wrong.
Okay, so probably we are multiplying the wrong thing here.
Maybe.
Let's guess that first.
Not yeah, just guess, right?
And yeah, let's guess that first. So is my get still watching this?
Sure.
Okay.
Maybe.
Okay. Okay, so we almost have something like a beacon oscillator. Yeah, it took a while, but finally a generation. We just have to figure out how to simulate like multiple ticks now.
Yeah, we have the simulate function.
Oh, it didn't work, man.
But did it change it? No, right?
No, it's still the same thing. Something is really
Okay.
wrong.
Yeah, I don't. Yeah, can you go back the thing that we are doing because I think it's right. Like the row should give the y.
Okay. So this is okay.
So it's something else.
Hi. Uh, almost there.
Okay, can you do a? How can I?
Let's see if we can have like at the border or something.
Okay, okay. Even if it's
There's something called polygon. I don't necessarily
uh,
know what's that.
hey, I think it's literally you do like +1 on the trans.
Oh, to add the spacing, you mean?
I guess so.
Okay, let's try that. Yeah, but this function is kind of cool.
Oh
I'm
yeah.
liking it. I want to change this if and else to something else, but for now, just for like a prototype, it's pretty cool. Pretty okay.
And I like to think about mapping the matrix then turn into a list.
Yeah, we have a matrix of booleans, and then we're gonna have a matrix of pictures. That's nice. And it didn't change anything.
Wait. Zoom. Ah. Wait, I think. Wait, a lot of zoom. Yeah, I don't think I have it. Can you increase this one? No, this one, I mean the one that we are adding.
Oh, 10. Okay.
Yeah, no, no, yeah, but like instead of 1, yeah, no, but not 10. 10 would be the size of the whole cell, right?
Okay, let's put 5.
Yeah, they should be apart, right? We should be 4 instead of.
Yeah. I'm kind of. Mm, how this translation is happening? I'm kind of curious. Actually, I don't. Doesn't matter, right? Because what matters is the translation at the end of the day.
Yeah, but oh wait, no, oh okay, yeah, the true list doesn't matter.
Yeah, the true list doesn't matter.
It matters in
Yeah.
which order we are mapping the matrix.
No, but that kind of doesn't matter because
No, no,
the location is already addressing
oh
the
okay,
the
yeah,
positions.
yeah, that's
Ah, crap.
yeah. Doesn't work like even those two, they don't grow apart. So
Yeah, pretty.
why?
I kind of want to like extrapolate a little bit
Wait,
just to see what
let's see
happens.
why. Yeah, but let me think.
Because the window is also like 400 by 400.
Let me see. Translate. And then you have the. Oh, you have this,
Hmm.
and then you go by all your. Then you should go. Yeah, for me it makes sense. The plus logic.
Okay, let's do the following. Let's pick the test grid. Let's change it to have 3 alive. And let's do a 3 by 3 instead of doing this. So let's go back to the test grid. And I just realized it kind of doesn't matter this size and this and how like how big this is the grid doesn't matter because these are two different dimensions. This the size of the grid it matters for modeling the grid. This 10 it matters for the window.
Yeah.
Yeah, but that means that I was not so stupid back when I did the test grid back then because it kind of doesn't matter. But okay.
No, no,
Um,
no. I mean, you had a grid that has only one alive at the center. How
yeah,
do we
no.
know if we are rendering a bunch?
Okay, that's fair. That's fair.
Oh my.
But now we have 3, apparently, supposedly.
In diagonal, right?
Yeah, in diagonally. I hope. Like I'm gonna see just one square. I know. I'm pretty sure, pretty certain.
I think we will see.
Nothing.
No. No, 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 no,
it
no. Yeah.
man, it was like here.
Because you put like 500, man.
Oh, but this is the reverse.
Wait, wait, wait. Okay, okay. So I see. The plus that we are doing, they are like just translocating the whole stuff
Yeah,
instead of like a space between the cells. So my
yeah.
logic should be wrong. So let's try to fix this. How can we grow they a bit more apart?
I think this has to be related to the picture type, man. This has to be in here.
What do you mean?
Yeah, what is arc, for instance?
No, 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 Lemus. We already have like all the abstractions that we need to do this, the border thing that we are wanting to. We only need
How are
to
you
do.
gonna do the border then?
No, no. Okay. Did you get what I was talking about? How we are rendering this stuff now?
Yeah, I think I got it. I think it's wrong still because something about the width and the weight is wrong because this thing is the opposite of should be.
No, no, no. Yeah, but that's regarding some kind of signal, right? It's not about like, how can I say? Like, suppose you have a number and then you have the size of the number, and then if it's positive or negative, right?
Hmm.
Okay, so like the size of the stuff is right, only the signal is wrong.
I don't think it's the signal, man. I think it's the order. Let's try this real quick. I think we are confused about
Oh wait,
who
wait, but
multiplies with
yeah,
who.
doesn't man both are 10. It doesn't matter.
No, no, no. Yes, but I first want to see the diagonal that we have here. If we get the diagonal, then we mess around with the sizes to discover whatever.
Lemus,
How
Lemus,
to
Lemus,
space
Lemus,
them
Lemus,
apart?
Lemus. Can you do something else? I get. Oh man, can you change those two things that are
It's the
between
same.
Hey, hey, go to parentheses. Change those things of places.
Who?
Translate, like change the order of the parentheses that we are using on translate. Yeah,
The order.
yeah, do that.
Like this?
Yeah,
I doubt it.
yeah.
Yeah.
Let's try it.
No, no. Let's try it, but I doubt it. It's fine.
The drums,
Yeah.
the drums, right?
But we need to get a way to put the border or a spacing between those things, man.
Yeah, but we already have all the
I don't.
weapons for that.
Which weapon is the one to add the
Okay,
border?
my weapon is only do some translate a little bit more so we can get empty space between the cells.
See?
It's the same?
Yeah.
Holy fuck, then I have no. Wait, that doesn't make sense. If we change it, no, it doesn't make sense. If we change it like the columns for rows.
No, but I also reversed this back then. So let me reverse this back to what we was.
Wait. We need to see the types, man. We shouldn't guess it. Like two things. On map pause, which one is the row? Which one is the column?
This is the row and this is the column. I'm pretty certain.
Okay. And the translate, which one is the X? Which one is the Y? Okay, rows and columns, yes.
Yeah, rows and columns. See?
Okay, but what
Okay.
about the translate? Which one is the X? Which one is the Y?
That's a good question. That's actually a phenomenal question that I don't know how to answer you.
Code? Maybe we have on the type definition, maybe not, but maybe on the source
No,
code.
no, the types, the modeling of the types is not great in this thing.
Oh
So
yeah,
the
it's only
translate,
float. Right? Yeah, so
yeah, it's only float.
take a
Float.
look on GitHub because but we can
Um,
also test it. But
we can make the rectangles back, like
yeah,
rectangle.
and then like only translate in one direction, right?
Yeah, pretty much. So this is gonna be translate, and then you're gonna have, I don't know, 0 and 50,
Like
and
it's
then this is gonna be rectangle solid 10 10.
Magenta is sending some motivation message on the chat.
Oh, which chat are you talking about?
Twitch.
Okay, so I'm not reading them, and I'm doubting they are um, motivating at all. I think he's doing the what a haters does best. So
Oh.
so you want to do pic? Now we need parentheses, and we're gonna do pictures. And then you're gonna have rectangle 1, rectangle 2.
Wait, what are you doing?
Just trust. Just trust me, man.
You only need one of those.
No, we don't need one. We need to see. We need to have a reference. And the reference, because the middle doesn't have any sort of indication that the middle is the middle.
Oh, okay. Oh wait,
I'm
but
adding.
no, but I bet we start looking at the middle, like this, the camera as. Know what I mean? But yeah, that's a good valid also to be the. Yeah, but hey, if the camera of. Oh, okay, that was why.
Okay, so the.
Oh, fuck! Wait, fuck! Wait. That was y, and a positive number was up.
Yeah.
Okay.
Okay.
So which one is y? Is that the second one?
That's a good question.
Take a look on translate.
The translate, we have both like the same
No,
size.
translate of the first rectangle.
Oh, it's 50.
So it should be
Is that,
y, this one.
yeah, so it's x and y
Yeah,
and positive. Okay.
put 50 also on that translate.
This one?
Yeah, the x of that. So we need to see if that will go like to the left or to the right.
Yeah.
Okay, positive on the y-axis.
It's up. Yeah. Yeah, and if the library works like with the center, in like the center is the reference, it kind of
Yeah,
makes sense.
I think that's our problem, Lemus. I were expecting that like y positive was going down because that's what the browser does.
Oh no, you were using JavaScript knowledge again, man. No, don't do that.
Okay, x is right. X is right. Let's just
Yeah,
invert the signal of the y, man, on our translate.
no wait, I'm can you repeat that? So we're gonna do, this is the y,
Yeah.
right? This needs to be
Yeah.
negative.
No. Yeah, but this is wrong. This should we use not the row. This should use yeah, the column. Yeah, this is the column. The other is the row.
And this is x. Are you sure that the first one, remember that the first one is
Yeah, the
x?
first is x.
And this, so one of these guys need to be negative.
Wait. Oh, okay, but that's not height also.
But this is width then.
Yeah. Oh, because we changed it, right? Yeah, now
Yeah.
you just multiply by
Minus
-1
one.
the y.
Both.
The
Oh,
y.
the y.
Yeah.
Okay.
Okay, I will deserve a nice. You don't need. No. Wait. Oh, okay. Yeah, it's the same. Yeah. Oh, but
Okay.
but you see that doesn't convey the intention that we are trying to do. Like you are doing minus height, but what the fuck is minus height? But if we put uh times -1, then we know that we want to invert the sequence. Like about intention, right?
Yeah. Oh man, I'm getting confused about this crap because this is x,
Uh
right?
huh.
And for instance, this is gonna be like this doesn't matter. We can interpret this as number one.
It kind of matters.
No, this matters for the size. Oh, this matters for the window. Okay, that's true. That matters for the window.
No, not for the window. It matters for the translate because that's how much we need to translate for it to be side by side. Because you see, we render
Oh,
on the
okay, side by
middle.
side. Side by side. That makes sense. That makes sense. Okay, but the column is the column is.
You see, column says like the X. Imagine a grid.
Oh, I see. Okay, okay, and this needs to be negative
So we go
because
down because we are man. See the way we
go
are.
down.
Yeah, down. Because we
No,
start.
man, we don't
No,
want to
no, no,
go
no.
down,
We
man.
want to go down. Why? Why is that? Because we start at 0, 0, and then we are going to the next column, next column, next column, and then next row. You see, we are going down with the rows. Well, in my head, that makes sense. I don't know if it makes sense for real. So let's try it first, and if it works, I can try to explain what I was thinking about.
That's a fair strategy, I think.
But
Okay, so
hey,
let's.
what is the grid that we are rendering?
We are rendering a diagonal grid.
Okay. But
Oh
which
man.
diagonal do you remember?
Yeah, it's the diagonal like top left, middle, and bottom right.
Okay.
Oh man. Okay.
That's quite a thing.
But I never used OpenGL. Maybe this is the semantics that they use there. I have no clue.
Oh, okay. That's a really good.
Like I only. Oh man.
Oh
Okay.
yeah.
Now you're talking.
Okay. So maybe could I share my screen for us to draw on Scholar Draw?
Yeah, sure.
Do you think that would be good for like the record or?
No. Yeah. No. Do the drawing. Do the drawing. If you can draw.
I'm not sure if I can draw. Yeah.
No, but
I sure
let's
can
try
try.
at least a simple explanation. So this is the zero, right? This right here.
Wait. Okay.
This is the zero,
Yeah.
the middle square. So we want to go up, right? We want to go up.
No. You have to think about the matrix to know why the column and why the row.
No, I think I already understood why the column is used to move in the x-axis, and the rows are used to move along the
You want to know
y-axis.
why the -1, right?
I want to know the minus. That's the
Okay.
thing.
Also, see that image. You can see that is the same image as the grid.
The same image as what? Sorry.
As the grid. It's the same image as the data structure.
No. It is. I'm
Oh,
not.
okay,
I'm not.
okay. So point me there. Where is 1, 1?
That's a good
It
question.
starts on 1, 1.
Or this one or this one.
Yeah, it's the left one. Yeah,
This one.
yeah. So the way I imagine that we are like mapping the matrix would be 1, 1, then 1. No, 2, 1. See, go to 2, 1.
Which one is here?
No,
Yeah.
wait.
Second row, first column.
Oh, okay. I wrong. So
I
one,
think it's
two.
1, 1, 2, 2, 3,
No,
3,
no,
right?
no, no. Like 1, 1,
Here,
1, 2,
here,
1, 3,
here,
2, 1,
here,
2, 2,
here.
2, 3, three,
What's the
1.
purpose of this? Here.
This is the way we are mapping the matrix. I'm pretty
No.
sure.
That I got it. I just
So
don't
no,
understand the
no.
minus. The minus.
Okay. You see. So if
Your mic is muted, man.
Can you hear me?
Yeah, but your audio is pretty bad.
A second. Is it better now? Hello?
Now it's better. I think it's back on track.
Okay. Yeah. So, Lemos, okay. So, when y is positive, he's up. So, mapping the matrix, we are increasing the y. So, the first one has like the lower y, and it will be bottom. And the next one, instead of being below that one, it will be above this one, because of the way that the y of the translate works.
No. I don't think we are on the same page. So let me try to explain from my point of view. So this guy in the middle, it's in the position 0, 0. Whatever that is. No translation. Is that it? That's my perspective on it. Maybe I'm wrong.
Actually, we don't know. We don't have, like, we don't know them. But I don't think so. I think 0, 0 of your window would be, oh. I think the corner of your window would be like down left. No, down left.
Down left here?
Yeah.
Oh, I see. Wait.
Yeah, but that has nothing to do with our thing. It doesn't matter for us.
But I'm going to repeat. I want to understand the minus. Minus is what's...
Okay. But that was the thing that I was talking about. So, man, the matrix. You already saw the way that we were mapping the matrix, right? So, what is happening with the number of the row? Is 1, then it's 2, then it's 3. Now, use this number to render. Render something as y1 would be anywhere you choose. The y2 will be on the top of that instead of below that. I could draw that, I guess.
I could draw that, I guess. Oh. Well, you can try.
Okay. Drawing is definitely a thing, right?
No, yeah, but I assume you...
Okay, maybe the drum will.
I think I'm mismatching, like the definition of the matrix and the coordinations is clashing with the window crap.
Yeah!
And in my mind, the thing in my mind is I'm not mapping one to the other correctly.
Yeah, but you will understand that pretty quickly.
Okay, so let's do an example.
Okay,
We
yeah.
have 9 cells.
Yeah, I'm doing that. Like, this here, it's the matrix. Matrix. Oh, that's tiny. How can... Oh, wait. I'm kind of lost. How can I move... Oh, we... Where is...
The width is 10, right? And the column...
No, the width it doesn't matter. The only thing it matters is like how do you translate and which column and which row you are. I cannot move the screen. How can I move the screen? How the fuck can I move the screen, man? Oh, okay. This way. So you can see my screen, right? On the left, we have the matrix. Let's render that, right? Lemos?
Yeah, okay. I'm not seeing your screen though, I'm not sure.
Oh, fuck, I forgot about that. That's important, right? Scrolling down. Okay, can you see it now?
Yeah, I can see it now.
Okay. So that would be 1, 1, right?
Yeah.
So that would be 1, 2, right? Wait, no. Actually, it's 2, 1, right?
Oh, yeah, sorry. 2, 1.
Yeah. And this?
3, 1, and then 1, 2.
Yeah, we only want these ones. Okay. So, like, we will render. Can you see my cursor?
Yes.
We render 1, 1, 1, 2, 1, 3, but we only care about these ones. Why?
Okay.
Because these ones are the ones that, like, the How?
Live?
No, the ones that the row are changing. So you see on that image, what happens when the row changes? That's one, and it goes to two. What happens in the image sense?
You need to translate.
No, not that. You don't know about anything about render. Like this matrix, when I go to 2, the 2 is below the 1.
Oh yeah.
See? Okay. But now let's render that. Let's render the 1, 1. The 1, 1 will be rendered here. It doesn't matter what exactly is this.
Okay.
But that will be in one place, and then we'll render 2. And how are you using 2 in our code? We are using this to increase the y of translate, right?
That's exactly.
Yeah, right? So
that's exactly what the confusion is.
okay, so you see the 2, 1 would be up here. You see why? No, but that's the way that translate works, because if y is positive, it's go up. The more bigger y is, more up he is.
No, yeah. Then shouldn't we use a negative value for y?
Yeah, that's why we are doing the -1, so we can get here.
I see. Okay, but okay. I think I just need to digest a little bit. Okay.
Like the bigger the y is, upper it will be on the screen. And the row is associated with the y. You know why?
Yeah, because the rows are actually controlling the distance, like the vertical distance.
Yes, exactly that. So because of this, when we go to a lower row, we get this number up, and this number will render this upper, because the y of the translate goes up. It's not as the browser. It's not the same system or coordinates as the matrix, the render one. So then we go with -y. So the higher is the y, the lower it renders.
Okay, now makes total sense. Makes total sense.
This ColleDraw is indeed really good.
But like I said, I never use OpenGL, so we need to do a little bit of research to know what are the semantics involved to render things.
Yeah, we did by experimentation, right?
Yeah, we did empirical here.
Yeah.
Just for loss.
Just for loss.
Okay, so let's go back to the code, because now I think we have something usable. So I kind of want to test, instead of using the test suite, I want to use the beacon.
Okay, just Mageta, if you are on the chat, can you say if is it good, the quality of the audio? Like, can you give this feedback to us? If no.
Say that you're making him deaf.
No, man, but no, because it's really loud. Yeah, I'm kind of screaming, so sorry for that. I'm actually screaming. Oh.
No, but I noticed that when your audio glitched, when you came back up, your audio is like significantly more louder. Didn't work, man.
What didn't work?
So I'm trying to.
It is working.
Oh, it's because the spacing is crap. Okay.
Yeah.
Yeah, it's because the spacing is crap.
Wait, Lemus. Let's just spend a second, try to fix the audio here.
Okay, so then we have a grid. Okay, so this is the grid. You just need to
yeah, Lemus. Can you give me feedback? I will just try to change the stuff here.
Yeah, no.
Can you hear me okay?
It's worse.
It's worse?
Yeah. It's noisy. It's noisy. Can you hear at all?
Is it better now?
Okay, so now we just need to add.
Wait, does it still has like noise in it?
It still has noise, but it's really. I think it's okay.
But
Maybe it's-
is it still loud, right?
Yeah, it's still very loud. I'm using 14 volume.
What about now? Is it better?
Yeah, it's significant. It's better.
Yeah, I turned off the fan, Magita, so it's from my computer. It's from like my headphone.
Okay, but anyway, how do we make the border?
Okay.
How we make the border?
So like my reasoning behind the border is only give some more spacing to have some white spacing between those. You see?
But how are we gonna do that?
Well, messing with translating.
No, but the translate is not gonna work. You know why? Because
If we adding all of those, they will just move together as we saw, right?
Sorry?
If we just add in all those translates that we are mapping, they will just move the whole picture together instead. So let's see.
Oh, I'm also low. Okay, so I don't know how I'm gonna fix that. Can you? Oh, you can increase my volume in your computer.
I don't think so.
Right click on my name and then.
On your name on Discord.
Yeah, on Discord.
Oh, okay.
There's user volume.
Oh, but it will have like a bad quality with that.
No, I don't know. My Geta can tell.
Oh no, it's kind of good. It's kind of okay.
Okay, but how are we gonna make the translation? I don't think that we can add borders with translation.
Yes, we can. It's just a matter of spacing, man.
No, but we're gonna apply the same spacing to everybody.
Yeah, that's the problem. But the solution is still translating. Unless you want to render like the white things, and I would think that it's not really good.
How can we compose?
Sure, we can do like a lot of white images to be the borders, but yeah, we could try that.
Oh, I have an idea. What do you think about this then? We have like I'm gonna do just for now, make cell, just to concatenate my thoughts, because
Okay.
I'm starting to have an idea. What about this is like a pictures, and inside here we have two rectangles, and one is bigger than the other, and one is black and the other is white.
Wait.
Yeah, and then we put like the black on top of the white one.
Lemos. Just try one thing. Instead of adding one, you can add 1 times like with it. Do that just for testing. Let's see if that.
Oh, you want to? I'm gonna use parentheses just for the sake of simplicity. I don't want.
Yeah, it's not there that you. Oh, okay.
So it's gonna be plus.
No, yeah, plus like 1 times with it.
The same thing here, right?
Yeah. Yeah, but wait. No, the -1 should be the last thing that happens. I guess.
Makes sense. Okay, so let me. Yeah, this is gonna have a bunch of parentheses in this case.
Oh, that's so ugly, man.
Oh yeah. What can I do for you?
Last
Be happy,
parenthesis.
please people. Be happy. Okay. So you want to test this. I don't know how this will solve problem, but let's try. No, it's not this. Let's try.
That would be poggers.
No, if this works, I'm not understanding.
That's like matemática de boteco. How can I translate that to English?
Okay, it didn't work.
Oh,
Okay.
give it a zoom. Oh, why? Why?
It makes sense for me.
Oh, no. Wait. Sorry, man. Sorry, I did it wrong. It's not with it. It's row and column. Yeah, I'm not even kidding. Not even kidding. Not even kidding. That's what I
in
was.
this order is column in the.
No. It's the opposite.
Okay, makes sense. This makes sense. But I don't see how you translating we're gonna get rid of the I don't know gluing problem.
No.
So,
You know how it will. You only don't know how. Okay, let's just test.
oh, I know. Okay.
What is the problem?
I messed up something. Don't know how.
Some parentheses somewhere.
No, but this is the same. How this is not a compiling anymore? This is the same. Okay, so it's complaining about types again. It's expected an int and an int. Line 20. Line 20.
Oh, is it the plus?
Oh, it's the.
Oh,
yeah, it's the same. It's the same.
Oh.
Yeah, it's the same. I need to add that from. It's exactly what I complained before. I hate.
Lemus, I'm thinking about getting a better headset, man. Like a Bluetooth one.
Yeah, after you go out of wires, like with no wires, you can go back.
Yeah, because the wire just goes to the hell and it doesn't work properly anymore.
Then you are like anchored to your computer.
Yeah, that is that.
I already like watched the meetings going to the bathroom.
That's fair. I could go with a nice, like, not headset, a headphone, a Bluetooth, and then actually a good microphone.
A good microphone.
But I'm not sure if I will spend that
Oh,
money.
it worked.
Why, Lemus? Why did it work, Lemus?
It worked because we are spacing them according to their columns and rows. So this is why you are making them distant.
This doesn't explain. First, explain why it was not working before, and that you already knew. Why it was not working before with only the plus one?
Because no, with only the plus one.
Yeah, why was not working?
Why was not working with only adding a plus one?
To every one of the cells we were translating to.
Because they are moving together.
Yes, that's the point. So.
And this is how you're making them moving different. You are multiplying by their unique columns and rows.
Yep.
So this is how they are moving different.
Oh yeah.
Okay, but is this correct? I already forgot.
What do you mean by correct?
Alive. Yeah. Okay. So we have.
Man, our render is already correct. We only need to manage the tick now.
Yeah, we only need to do animation, but unfortunately, we already passed the time.
Yeah.
But okay, so this is alright. This is the cells now. So
yeah. By the way, if you have the time, I could stay here, but only if you do have the time.
Okay, let me see if I have the time. Because I want to make this. It's gonna be a ginormous stream. I don't care. Okay. Let's continue then. This is simulation time. Okay. This is simulation time now.
Oh yeah.
Let's go back here. So at some point we have. Wait. Okay, so I can stay. Okay, so it's simulation time, which means that we're gonna go to main, and this is what.
Oh yeah.
Okay, so this is a monad. Let's start with this. So, do you remember the thing that I explained to you back then? I already explained to you the notation syntax sugar.
Yeah, it's just calling the bind and bind.
Yeah. But I kind of want to know what's the type of this. So I think we already researched this function. So let's do what's the type of the function simulate. So we have a caller, we have an int, we have a model. Which one is this? It's the 3 from the car. Okay, so it's this model to picture. model to picture.
Why do we have
Color int.
Why the
color
fuck do we have a
int.
call?
Oh, this is the model. Okay, so this is the initial. This is the initial thing. Okay, so
Okay.
this is the initial grid for us.
Okay.
Okay, that's fine. This is the function that we just did.
And then the update.
And we also have this, but we need to see the type of this
Yeah,
type of evolve.
that it probably has to do with the same kind of it's the model, right?
No, it's complicated.
Oh no.
It's complicated.
But it has the model.
It has the model.
And that's what we want, right? Man, I don't think we need anything else.
No, but we need only this function and we are done, right?
Yeah, I think we can just ignore those parameters, Lemos. Those are probably like t as in time, right? And we don't need to know the time.
No, which one of these is time?
Oh, okay. Yeah, neither of those because it's float and viewport.
No, yeah, that's the
Oh, okay. Viewport, it's probably the size of the thing on that instance. That's probably
but let's read this function. Evolve.
okay. Yeah, but like what I think is the viewport is the current size of the window, so you could do resizing, right?
Evolve. Okay, so there's a viewport.
Mm-hmm.
There's a float and there's a.
What is this float? I would expect this float to have to be time, but I'm not sure. What are they using this float?
This function.
Oh, they are just ignoring, as we will do.
They are just ignoring.
Yeah, and the rest of it is just the advancement, the advanced generation of grid.
Yeah.
And the render is the render that we are. Oh man, we already finished it. We can just call this function, I guess.
Okay, let's try this then. So, display. Okay, so this name of this function will be play game.
Like.
It receives whatever is this. So this is the.
Well, that could be on main also, right? But doesn't matter.
Yeah. Okay, so we're gonna have this is the float, and then instead of worlds, we're gonna have grids.
But are he defining the viewport there on user file?
I think that is something inside the thing. Let's just import this simulate, this interface pure simulate whatever, and let's see what happens.
Okay. Yeah, but I
don't
think
this-
I think you will have an error on the view. Oh, okay, because on the other example he was using the whole path, right? To
Okay, so
viewport.
let's ignore the viewport. Let's ignore the float.
And the rest is just the one that we already have.
Wait a minute, look at this comment. Consume some random numbers to advance the simulation.
Yeah, he's generating numbers somewhere, like their angle, scales.
Oh, this is just. Man,
Hmm?
this is just like this, isn't it? Read and then advance generation.
No. You can just advance generation and remove the grid on both sides. Just remove grid on both sides.
Yeah, reduction enter, right?
I would call the point freestyle.
Yeah, no, but this is also known as point freestyle.
Okay.
Is this gonna? No way. This is gonna.
Oh wait, but we need to call the simulate. Oh no, wait, Lemos. Yeah, this name is wrong. Yeah, now it's right. Yeah.
Now we're gonna do play. So this is gonna be simulate. Let's go back.
Oh man, I'm so excited with this
I'm
project.
so excited. this works. Holy man.
Oh man.
Wait. I think that my thing is it's lagging. It's just lagging. Okay, so we have all these.
Yeah, in the future we could pass the viewport to get the size of the cells and all the other stuff, so we can like resize and still maintain the, you know.
Okay, so
Well, not necessarily. Maybe we don't want that.
background color. I think we can maintain white.
Yup.
Okay.
Number of steps per second. Okay. Oh no, that's too much, Lemos.
Okay, so 5.
I think that's already too much. Let's no, yeah, but yeah, it could be 1 or 2, yeah.
Beacon oscillator. And the render we already have, and the evolve is advanced game.
Yeah, let's just see the type of renders, right? Like, is it model to picture, right?
The render is model to picture.
Oh, okay, so our model is a grid, right?
Our
So
model. Oh, you need to add something here. You need to add the 1010.
oh yeah, but it should be the first argument, right?
Yeah, and then we are partial applying, of course.
Of course.
No, but this is wrong though. Because we need to do like this.
Yeah, it was right.
Here. Oh. I don't know how to write.
Oh, and do you know why this is really no?
I'm really curious to see if this compiles. Okay, it does not compile, which is fine. Okay, so let's go one by one.
Oh, it's a bunch of
There's
things.
a bunch. Okay, so this is where so it's complaining that
The grid with the size of the thing. So we probably forgot to change something.
display 18. I'm not getting.
Like render.
No, but it's complaining about something that we
No, render. 20. Oh no, it's right already, right?
Oh no, you're right. This is big. And this is not correct. Now it's correct.
Oh, I was not even aware of this one.
But you're correct. Okay.
But we are not using that, right?
No, you're not using that.
Okay.
Okay, so this is new error. So it's complaining about line 29, and that is display game. Okay.
Oh.
So it's complaining that couldn't match viewport float grid to T with actual type IO. What are you talking? What are you talking? I'm gonna guess parentheses. This is always my first guess.
Yeah, that sounds like. Yeah.
Oh!
Yeah, that was actually.
Holy.
Yeah, because you were passing one more than expected, right?
Okay, so let's go to main, and instead of doing task loss, we're gonna go play game. And now we're gonna build it and see the chaos probably. Okay. Huge moment. Huge moment.
It will go just fine.
I don't know about that.
I'm kind of confident.
Hold. Come on. It's working!
Oh yeah, Lemos. Lemos. Hey. Easy peasy.
2 hours and 17 minutes.
No, the simulate.
Yeah, no, the easy peasy was, man, types are documentation. I'm pretty much convinced at this point.
Yeah, they didn't make a, well, okay, maybe it's a good job, but I would like other way.
No, I would like even better documentation, but
Yeah.
that's the thing that when I enter data risk, people told me you don't always need like a full documentation in a natural language to get things done. The types are already indicated to you,
Yeah.
and that brings intuition to the equation. That's
Not only type. I think I literally already said to you to take a look on the source code.
Okay, but the thing that sucks is that really good game of types we would need to put them by hand.
Oh, parsing, right? Hey, but how would you import those stuff? In which format? Where you?
What's the type of simulator again?
Why?
Oh, this is because I'm feeling that the simulation is too slow.
No, that's ticks per second. You can just increase this number.
Oh, I want to let you. It's the opposite. Okay, It was being done. Okay.
Lemus, but where are you going to get this data from? In which format? Where you will get those?
Games of life.
I don't think you will find some.
Okay, so examples of code games.
I know it's a pain on the ass to do that with lists, but I don't see how you could.
Like this one, for instance, you know?
Yeah, but how do we import that? In which file format?
We would need, like, I don't know, maybe this could be like a binary file with a bunch of ones and zeros.
You know what we could do? We could do like a TXT with doing like X's and like zeros. I don't know.
No, but that we could do that, but the thing that sucks is that we're gonna have to do the parsing ourselves.
Yeah.
And that's okay for me, but I kind of want to see something
But
more...
wait. But that's a pretty easy parsing. It's literally like spaces to divide between.
No, but I will have to go, like, for me it's fine. I'm totally into that. But we're gonna have to go to the I/O, and we're gonna have to use monos this time around. And I just want to see something more...
Okay, let's just do one of those by hand.
Let's do the blinker.
Blinker? But it's as easy as that one. Oh, just because you already have it, right? By the way, Lemos, we can do some improvement, man.
Oh yeah.
Regarding either two things, or doing a grid that wraps in itself, like when you go out of border, you go in through the other side. You know what I mean?
Oh, that. Oh man, I don't know. That's fancy.
No, that's easy. That's not. Yeah, it's fancy, but it's not hard. Yeah, but it's not hard. Or we could do the hard thing. Maybe. Let me see. Actually.
Oh, it's working. Use the blinker. Ta-da! See?
Yeah, I can see. I was thinking about those ones that just move infinitely and we can like just scroll to like follow them. I don't think we could do that because that works for our handling but not for our matrix.
But I would be totally satisfied with like just having
The wrapping, right?
No, not the wrapping. I think that would be cool. That would be fancy. But I just want to be able to pick. I don't know. First, we need to make sure that we can find on the internet, like games of lives, like in CSV or something.
I don't
And then we can
think.
make the parsing. Right? And this is we can do these things like this.
What do you
This
mean?
is like changing the colors of like depending on
Yeah, that's
how old.
that's not only changing the colors, man,
No, this is changing the colors according to your age, I think.
and a lot more stuff. They are using other system too. It's not a grid as we are talking.
No, it's they are using, I don't know, hexagons or something like that. But we can do the same thing with like squares.
Yeah, the color part, yes. But
Yeah, no, the color part would be great. But we would have to change the model. We would have to change our modeling because we don't have the age inside the cell. The age does not know how old it is.
but we don't have to change our types. Well, not have to change the types of our functions. You only have to change the type of your cell and the implementation of the advanced generation and the render. Yeah, we already have good abstractions. Hey man, but can you do like a nice game of life there? A more complicated one there? Let's do
I
it.
have to do it by hand.
Yeah, but I want to see a cool one. Does it need an... Okay, a moving one would be... Oh yeah, not that one. That's too much.
This one would be bonkers, right?
Yeah, but that's too much. That's too much, Lemus. Do you have a moving one that it's like...
We can do the glider.
Oh, okay. Yeah, I would like that one. It's
I
pretty
need to
tiny.
stop- Yeah, but I need to stop the scrap How do I stop this?
I have no idea.
Okay, so it's 3.
What is the initial state? Could be either... Oh, could be anyone, right?
Could be
try to double click or right click it. Save as image.
Save as images.
Be careful with our folder.
No, but that's fine. Let's just memorize. This is okay. 3.
Okay, but make it a good grid and make it start on the corner, right?
Yeah. I'm not hearing you anymore. By the way.
You are not hearing me?
Now I'm hearing.
Oh, so you were all the time. I was just not talking probably. What is that?
Oh, but I think the matrix needs. They have to have the same.
Oh, but that's good. Do you know why?
No.
Because we can do only a time glider and then just concatenate with empty matrices to do, you know? And also with that we can expand our grid as it goes.
Is that possible to expand the grid as it goes?
Sure, because we have data and we are modifying the data. It doesn't matter what you are doing with that.
Oh.
You see?
Okay, so.
But for now, let's just do the glider in
Okay, so let's pick whatever, like a grid of whatever. And
Yeah.
this is gonna be the glider. So glider. It's gonna be. I think that 6x6 is okay.
I don't think so. Like,
It's okay.
it's okay for you to put the glider on, but once it starts to move, you need a little bit more to see.
It's gonna. So this is alive. This is alive.
Okay.
This is also alive. And then we do alive, and this is also alive, and everything is dead. This is dead.
Is that right? I don't think I saw this format, man.
Let's go there.
Oh, okay, I saw that you have another live there.
Oh no, but it's wrong. No, it's right. It's wrong. This is the glider. One of the states of the glider. The problem is how you're gonna expand.
Wait, are you
I'm sure. I'm sure. I'm sure.
Okay.
How are you gonna expand the grid as the glider moves?
No, expand, we don't have a way now, and it's the way that I said to you. We would have to concatenate things on the grid as it goes. But what we can do by now, it's just like get the initial grid bigger, just so we can see it moves a little bit. Then he will go out of grid eventually.
The thing is that I think that's gonna be fast. You know?
It's just, yeah, the tick that we are now, yes.
Oh fuck! I already lost count. I hope it's right.
Oh no.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13. Let's figure it out this way. 3, 6, 9, 12. I said 15.
I was not paying attention.
Okay, so 3, 6, 9, 12, 13. 3, 6, 9. Okay, so it's missing one there. And I think this is also the case. So 3, 6, 9, 12. Also missing one. And okay, I think we are fine. I
Yeah.
just want to make the this thing now like this.
Yeah, you need to see more.
Okay.
Wait, but I think you need more rows. You only have just a few. Yeah,
You need
because
more what, sorry?
rows.
Rows.
Yeah.
I think so.
Yep, because he moves on diagonal, right? So
Okay, so let's do.
no, that's columns.
Oh, so we were talking about this. Like this?
Yeah, to be a square, right? So,
Oh, I don't know if this is a square.
but it's okay. Let's go.
Okay, so let's go.
Yeah, it's quite a trouble to.
Yeah, that's the thing that sucks about this game of life. If you don't have already the parser and like files.
Lemos, do you know what we could do? It's let the user set the initial state and then play button.
I didn't. You cut it from.
Oh.
further.
You let the user make the initial state on the program by clicking, and then you press the play.
That is fancy.
Oh yeah, but it solves your problem.
But I don't know if you have that capability with gloss.
Yeah, I'm not sure if you have the point and
No, but
stuff.
don't we have like a shortcut to reverse the whatever the heck?
What do you mean by reverse?
There's some keys. Okay, so quit is ask, arrow keys move, left click drag. Okay.
No. That's for moving your
Oh, it's
window.
moving.
Yeah, but it doesn't go forever. It will reach the end of the grid and. Oh, okay. It doesn't go out of grid.
Oh yeah. Okay, makes sense.
Yeah.
Can I reset OR?
No, reset viewport. If you change the size of the window and press R,
Makes sense.
you do, man. If you,
Doesn't it have a key for like reset? What the fuck?
it doesn't make sense because it's a program, Lemus. You have to reset the program.
No, yeah, but could just like I don't know. It's fancy as heck. Why the heck I can just have to see the thing again?
I don't think that what you are asking for makes sense. The only way to reset the program is to reset the program.
But it should has this thing automatically. That's okay. But anyway, it's working.
But hey, if we have a way to use gloss to do like clicks, we can do what I said.
But that's something that I don't know. Man.
What don't you know about the
I don't
click?
know if you, no, I don't know if you can have like. We need to see some examples.
No. A button is anything. If you have the click and you can detect the click, you can make your button.
No, that's I agree.
Press dot. Press dot on GitHub. Yeah, actually that would be better. Yes. Oh,
Not game.
reading user mouse click position. Oh,
What's the state of this system? Okay, so you want to use play. Okay, so there's a play instead of a display. Okay. Where is display in this? Okay, so apparently there's a function called display. Is that a thing? Oh yeah. Okay. You want to use play instead of display. It explicitly takes an argument type event, word to word. Word could be your board, describing how to react to events. Okay. Oh, you need. Oh.
Oh.
Or you can have a player now.
No. That's a type that they are defining. We don't know how they are using inside the class. So you always can have a type of any sort.
No, but it's saying you have the current player, which will change after the next move. You can describe very simple things.
Man, I just want to know about clicks. Like, oh, yeah, that's the thing.
Oh, it's using alternative. It's using even like fmap. Like, this is the same thing as fmap for you. Mouse clicks are received as a pair of floats corresponding to the position of the mouse in the drawing.
But where this happens is when we use play. It has some.
No, let's handle keys.
Oh, maybe you pass some handle keys too.
Let's continue reading. So you need to translate this position to appropriate coordinates. This is what check coordinate does. It divides a float by the size you have picked for the drawing and checks with subdivision of the board
Yeah, this is translating the position of the window to the system that they are using of positions.
Here I use a guard and this to have a declared presentation of various cases, but you can use if then else if you want to. Okay, so this is this is just checking, right? Finally, hand keys can detect mouse clicks.
Oh yeah.
Check that they correspond to a position in the board and react appropriately by calling push token.
Putting out together. So yeah, basically it's play. Oh wait, hey man, you see, it makes total sense, right? One is simulate. You don't need to interact on simulations.
Yeah, simulation you don't interact.
And the other is play. It's like, oh man, okay, I really like those names. But hey, I think we have to wrap up here. Like, No, 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 man. To do like some more. I think we could do the wrapping of the board, but do the plating would be too much for today, man.
No, not for today. I'm talking about future, potentially future sessions.
Okay.
So here he is, the glider.
Oh yeah, I'm quite happy with that.
Let's just spend like 5 minutes to
Okay.
like refactor this thing.
Okay, okay, that's fair.
So let me think. What would be the name that you call this?
What?
The translation.
Oh,
part
wait,
in
wait,
Haskell.
just a second, just a second. Okay. I don't know.
Let's do x-axis. Let's do that like that. X-axis. You receive a column. You receive the width, and you return this.
I don't think this should be a function.
Why?
Oh wait, maybe it does.
Then you're gonna have the same thing like y.
Oh, okay, okay, yeah, you are completely right.
So it's row and height. You just put this, and you're just gonna put. I do believe that this requires parentheses in this particular case, but it's much better.
Yes. Man, but Lemus, that's so weird, man. Have you ever spent like some time to looking at precedence and evaluation? You have to take a look at that, man, because that thing about parentheses,
I think we could just get around doing this.
it's the same, isn't it? Like apply.
I'm not sure, but I can try to compare and see what happens.
Oh, okay, okay, I see. Yeah, that's the same case with pipes. But I'm not sure if yeah, but that's not pipe, right? That would be the inversed pipe.
Oh yeah.
So I guess you should change the order of those things between the operator. Maybe, I don't know.
Okay, so this is the glider git, so this is the initial state.
Oh yeah, we need to update those comments. And also, we could format this thing better, man.
We could do something like
Especially the test clause is off.
I think we can just get rid of this.
Oh, nice.
Okay, let's see if this compiles. Yeah, it's the parentheses thing.
Yeah, I think it's probably just change the order of the stuff that are between the operators. Literally reverse, I guess.
What do you mean?
You see, you have the dollar, and between the dollars you have stuff, the operands. You have like translate, x-axis and y-axis. Just change the order, like y-axis, x-axis, and then translate. I think that's
I
just.
think that's harder to read. I'm gonna put parentheses.
Yeah, I would prefer that. But I also wouldn't use dollar anywhere.
No, sometimes it makes more sense. It makes a lot of sense to use.
I would prefer the pipe, man.
Okay, we just have to
Hmm?
think about this whole wording, whatever. So that's complaining about line 24.
Okay. Can I see the warning if the things about the tabs?
Let's try this first.
If it's the thing about the tabs, the only way to solve it is to. Is it tabs? Yeah. Okay, you can do either two things, Lemus. Either you can configure your VS Code to show like white spaces as
Oh,
characters.
it worked.
Okay, you delete any random.
Yeah, that's pretty much. What's the type of play game? It's not your okay. So play game.
Just to get this beautiful, right?
Nice.
Oh, that was loud.
2 hours and 38 minutes for 20 lines of code. Yeah, I think it's okay.
Well, it's Haskell, right? But hey, that. Oh wait, that is pretty ugly. 13 and 14 could be far better, man.
How so?
Just. Just having only the parentheses that we actually need.
We don't need these external ones.
So okay, let's. You also don't need the first yellow ones because the precedence does that for you. Like you first multiply and then you add.
Okay, that's true.
Oh, why do we have? Oh, plus one. Okay. Oh no 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 no! We are actually wrong. Yeah, but no no. Wait. Let just like this, just so I can think.
All of these needs
a
to
bit.
happen before this.
Like-
we need these parentheses because of this plus.
Like the one needs to be multiplied by the column. Oh, actually,
this works.
yeah, actually this looks right, but then we don't need the ones.
Where?
Like this that we are doing looks right because that would be like the column times the width, so that's the normal like translate, and then we are adding 1 times the column, but you see 1 times something is only something, right?
No, I agree.
Yeah, but yeah, no, wait, let's not do that. Let's put this one into some variable because that would be the distance between the border size. Call it border size. Yeah, so border size times the row. Yeah.
Let's see if it compiles.
Yeah, and let's tweak that to see if actually does what it says, right? And it is a float, right? So we could try a thinner border.
Oh, this is new. Couldn't figure out C compiler information. Make sure. What the heck?
That's
This
real.
is new? This is totally new. I think.
Warning.
It's just okay, but it's still working. Regardless.
Do we have borders?
Yeah.
Okay, now try to change the border size.
Let's change it to 2.
Imagine if we had like rot reload, right? Change
One more.
rot reload, like changing the code,
Oh,
and
that would be fancy. That would be really cool.
but that's not possible. Oh, in Lisp, I think it is. Maybe in Lisp it is
Yeah,
possible.
This is the thing that Mageto was talking about, I think today.
Yeah,
And he was talking to me about that yesterday. as
You can update the code run if I'm not mistaken.
well. Yeah.
Also heard that from my Git.
Which is pretty useful.
Yeah, depending on what you are doing,
Yeah.
definitely work it, right?
It's bigger the border.
So let's take a look.
Oh, we have a glider. We have a glider.
Let's take a look again on the code, just to see if we can prove a bit more.
I don't think we can have a way with this from integral crap.
Wait, but on the y-axis we have more than we need, right?
Sorry?
On the y-axis line we have more than we need, I guess. Yeah, we do. We actually do. Yeah. Y-axis. The first parenthesis you can delete.
No, we can't.
You.
Because this plus needs to occur before this.
Oh yeah. Okay, you're right. Well, there you could use the the dollar sign. Yeah, there you could use the dollar sign. Yeah, it would be basically like -1 plus dollar sign, the expression, I guess.
Be something like this.
I would think so, and in that way. Oh, hey! You can delete the parentheses now. Because the function call occurs before the, I guess. Not sure.
I think that you can't remove these parentheses.
Yeah, let's do with parentheses. Let's see if that
Let's
works.
see if this compiles. Okay, it does not compile, and I know why.
Okay.
Because this, when you're using this type of notation, you actually need to put. Okay, you're gonna have to use double parentheses.
What the?
This is the way that this.
Yeah, at least there's like a spacing. Yeah, so it's like ML. Yeah.
Yeah. Okay, so the only thing that I want to improve is this if and else, and then we are done.
Okay.
So how can we get rid of this?
Can you do the case thing?
Yeah. Case cell off, and then you do that.
Oh yeah, that's much better.
Do blank. If the cell is alive.
Wait, that's a switch case. That's not a pattern match, right? Because otherwise you would be binding the value to that and to alive, right?
Sorry?
That's switch case. That's not pattern matching, right? Because if it was pattern matching, you would be binding the value of cell to dead.
Oh, no, yeah, this is not pattern matching. This is
Oh.
like a switch case structure. Pattern matching is redundant.
Oh, okay. This is pattern matching. This is not switch case.
It's, I think it's expected.
Do you have the pin? Oh, that's.
What I'm.
Oh wait. So it's better for you to use like.
No, it's still saying that pattern matching is redundant.
Of course, because you are always matching the bind. It's already a wildcard dead. This is identifier, not the value. Do you have the pin operator in Haskell? Search for that. Oh, yeah. Search for pin operator elixir, so you know what it is.
Pin, like this?
No, pin
Oh, pin.
operator elixir. Yeah, I would like that in a bunch of languages, man. Actually. Well, you can do it literal. With literal, you can do that in F#, I guess. Yeah, you can do.
But what is the thing at the end of the day?
Is instead of using that as an identifier, if you pin that, you would be matching with the value of the identifier that before that scope. He will not do the binding. I'm not sure if it's clear. Look.
Okay, but we can. I think we can do the same thing with the.
Let's use guards. Yeah.
Maybe we can achieve the same thing with like a cell who's dead. Then this is gonna be blank.
Oh, I really like the blank abstraction, man. The blank abstraction.
And then otherwise, right?
And it's also a lot faster, right?
I'm gonna do some of this.
Can you do like cell equals alive? Because when it's not a. Okay, yeah, it makes sense. If it's not that, it is alive. By the way, the otherwise, it has to be the name otherwise in Haskell, or?
No, I think you can use things like this.
Oh, okay. It's strange because when you say otherwise, in other languages, he would.
Oh,
Hmm?
he's complaining about found hole.
What the fuck?
Okay, so apparently the placeholder it needs to be otherwise.
Oh, that kind of makes sense in a way, because if it could be anything, then he would complain about, in other languages at least, oh, you are binding a value here, but it's unused.
Yeah. Yeah, I think this is okay. What do you think?
I think it's okay. Yeah.
Just remove this.
Oh, just see if the comments are not lying,
We don't have any comments.
and the other files.
That the only comment. Okay, we have comments here.
They could be lying. No, I'm more talking about the. Yeah, this could also check that, but I'm not. I'm talking about we copied and pasted some stuff, and they had comments.
I already removed the comments are correct. We're gonna check.
Mhm.
The board, the game board. This is a cell, and this is that cell. It's only written cell here, right? State 4.
Lemus, doing games is really nice, man, for like problem solving, right?
Oh yeah. Okay, so this is alias for cell.
This is not a particularly complex one, but even though, even still, we have some things to think about.
And this one is the location, cells position in the grid. Okay, I'm okay with this. And then the comments here, I don't like this. Okay. So this is setting window for the game.
Yeah, can you do some indentation on the dollar rectangle solid?
Where you want indentation?
Like the line 19, I guess.
19. Oh, you want indentation for this, like what? For like what?
Yeah, on the dollar. If it makes sense on Haskell, I'm not sure if.
Yeah. No, but I'm following the DSL. This indentation style is the from the boss.
Oh, okay, nice.
So we have the number of steps per second. We have the initial state of the game, and so this is the function to convert the grid to a picture.
Lemus, can I do a challenge for you?
Well, yes.
Well, propose a challenge, right? Then you say if you accept or not. Could you get a video or a GIF for a game of life? Maybe, I don't know, have the code in a picture or so, and share that somewhere, either on your LinkedIn or your Twitter, not Instagram, but something that would be relevant.
No, I would definitely make something on Instagram about this function to adventure.
No, okay, but what I mean is the intention is getting you. What are the names that Belani calls it? Oh, by the way, we should tell this to Belani.
Well, maybe, I don't know.
Do you have like LinkedIn?
Yeah.
So okay, sharing this on LinkedIn would be a good start.
No, we have some games here. It's okay, I guess.
But you see the idea that I'm trying to pass, like for
Magenta is saying leverage. I think it's the word that you want.
yeah, it's reputation, I guess.
Okay, yeah, that makes sense.
Oh, okay, Magetta was typing.
Play the game.
Don't remove the parentheses.
Okay, so
Leverage.
man, I want to change this thing.
Oh, what?
Let's pick the glider here, and I want to change this function to, instead of being like this, we're gonna receive a grid.
You can use the simulate on main, man. You don't need the play game there. Oh, okay, I see. Okay, play game and choose a grid,
We're
right?
finally gonna have a read.
Are we?
Oh, it already exists just now. Okay, so this is the readme, and now we're gonna try to explain. Okay, so this is the game of life
Yeah, because it's kind of ready, right? We can.
implemented in Haskell.
Oh, a GIF would also be really nice there.
Oh no, a GIF here would be like top
Poggers.
but I already forgot how to do links in.
Magetta, if you are there, man, do you know about the pin operator in Lisp if they have it there? Like maybe using macros, I don't know. But the thing is, instead of using that name, that identifier, PKs. So if you use like a name of a variable on the pattern, instead of like binding that, you will compare with that value.
Look at this, man.
Or what?
Look at this.
Oh, I saw this. Yes, I already saw this.
I didn't.
I can get the labels.
Haskell,
Yeah, what I mean, Magneto, is that like when you put a pattern on the left side of the matches, the name that you put there, it will be a new binding, right? Yeah, like, but A would be a previous declared variable with 2. You see, he would not bind 2 to A. He would compare if the match is valid, substituting the pin. Yeah, this is. So do you have that in some Lisp thing? Oh, even the dependencies that you are using, nice.
Dependencies are better word.
Oh, implemented here and then the episodes, you know.
Some dependencies.
Links. In Lisp you can expand with the map. Oh, so you can like change that to a guard, right? So match anything and then compare it if it's equal with a guard. Oh, I see. Yeah, that would be pretty elegant, I guess.
If you want to see a different game, not lighter, then the radical and use play game.
Yeah, when we are done here, I will get some water, man. Like
You got some what? Sorry.
water, like real water, not
Real one.
yeah, not sparkling water.
Yeah. Okay. So what else is important? We already have the dependencies. We already have
Links to Twitch or YouTube or both, like implemented here on those episodes or this channel. Or oh, by the way, you know that it only lasts some days, right? Like the episode on Twitch, the VODs.
Yeah, but I'm always uploading to YouTube on the same day.
Yeah, and now it has good quality, so yeah, it's okay.
No, but I don't think this is necessary, man. Like, to have in the README, because that's gonna be all the READMEs will have that.
What?
I think that's
No, it's just like put the link to the YouTube somewhere, man.
we also have file.
Yeah, that should be a link to the GitHub, right?
It can be. I kind of want to just have like the focus is the organization, not us.
Yeah, that's why we want links like YouTube, right? And Nekoma GitHub.
Okay, I'm not gonna put this.
Fair.
Okay, I'm gonna just put.
Yeah, then instead of putting the name, you could put our GitHub username.
Oh, okay. So this would be. I think you is Ribeiro, something like this, right?
Yeah, but Tomás after Ribeiro. I guess.
What? Sorry? Ribeiro what?
Tomas.
Tomas.
Yes.
Okay, so YouTube, Twitch and YouTube is enough.
Mhm.
YouTube, I have this.
You can even say like, oh, build it live on Twitch.
So copy link. Build it live on Twitch. And verified.
Nice. Normal macro that works as a quality operator. Okay.
Okay. I think we're done.
Nice.
Okay, so you can end the stream now. I will push this to the video.
Okay. So bye bye, Mageta from the Twitch chat. You seem like a good guy, like a little bit strange with the parenthesis stuff, but I hope to see you
also,
again.
Stops being a hater. That's also a pro move. A free tech tip for you.
It's not hate, it's incentive.
Oh yeah, okay.
Bye.